Yes. Right. It's working. And 8:40. Time is going like a aeroplane, right? We spend time to earn money, and we have to use that money to have the time. So basically, what we earned, we don't know. What we spend, we don't know. That's a problem. Okay. Hi. Now, today's session is entirely discussion, and it's fully discussing part is there today. Today, mostly explanation and talking about Weber part. Weber part. So that is somewhat complex to understand. Somewhat complex to understand. So yes. So where did we stop last day? Last year we stopped. Give you a book. How I stopped last day class? So did I was explaining a graph, right? I was explaining a graph. What was that graph? Right. Okay. I was explaining a graph. Okay. Now, anyhow, today we will start a new section, vapor. If not, we can call it as hydrometry. We will start a new section, vapor. If not, hydrometry. Anyhow, today we have to start that. But I want to explain more about that graph. But last day I explained detailedly, right? Last day I explained detailedly, but I could not give a note. Am I correct? Did I explain that graph clearly? But I could not provide a note. That was the problem. Okay. So keep one page blank, and after interval we'll come to this. Okay. Start putting the topic unit 4 heat vapor. Unit 4 heat vapor. If not, you can write down unit 4 heat hydrometry. Unit 4 heat hydrometry. Now, when it comes to unit 4 heat, what have we discussed so far? And how long have we taken to do those sections? So that is really concerning, right? It's really concerning. So when talking about unit 4, what have we discussed so far? And what to be discussed so far? We discussed completely thermal expansion. Thermal expansion, we discussed completely. So thermal expansion divides into two subsections, solid expansion, liquid expansion. So once we completed thermal expansion, then we started discussing Gas laws. We started discussing gas laws. And gas laws also detailedly discussed. Then we started calorimetry. Calorimetry. So currently we are doing calorimetry actually. We are actually at the end of the calorimetry section. I want to explain that graph, and if I can do 2-3 questions, this section also will be completely discussed. Will be finished. Calorimetry. Only we have discussed these 3 sections up to now. What to be discussed? What are the sections that we missed so far? Generally, unit 4 heat starts from thermometry. I didn't teach you what is thermometry. Thermometry is to be discussed. Thermometry. I didn't discuss thermometry yet. According to the order, first I should teach thermometry. Then I should teach thermal expansion, solid and liquid. Then gas laws. Then calorimetry. Once I completed discussing calorimetry, I should teach you thermodynamics. Then hydrometry, this vapor section. Then conduction and convection. But even though most of the teachers, they starting thermodynamics after completing calorimetry, but some teachers, what they do, they start hydrometry, then they go to the conduction, then convection. Finally, they touch thermodynamics. So then, according to the order, I discussed these 3 main sections. I didn't discuss thermometry. It is theory-based section. That's why I didn't do at the beginning of the unit 4. But now I feel this is the time to do that also. Now it's a time. So I'm going to do it. Okay. So now vapor. Unit 4 heat, hydrometry, and put your subtopic. Vapor pressure. Your subtopic, vapor pressure. Now, when you consider all these sections, what section is to be complex to understand? There is no doubt. Hydrometry. I missed hydrometry. Hydrometry is difficult to understand. There is no doubt. Hydrometry is difficult to understand. Other than hydrometry, are there any complex sections to be understand? Yes. Thermodynamics. Other than thermodynamics and hydrometry, remaining sections are easy to understand. Direct application, convection, conduction, straightforward equations. You can understand. How long, in order to explain hydrometry, I think that I want to explain the same thing again and again. So it's your responsibility to keep your attention and keep your focus. We'll finish this unit 4 detailedly. So then we can start 6, 7, 8, 9 in the current sections. Okay. Now vapor pressure. Subtopic vapor pressure. Okay. Now already we know, when we were learning about gas laws, I explained how this gas pressure is formed. Then what is the difference between gas and a vapor? That is first question. What is the difference between gas and a vapor? How are you going to differentiate gas and vapor? How do you differentiate gas and a vapor? What is the difference? What do you feel? What is the difference between gas and vapor? I'll ask from you. What do you think the difference between gas and vapor? Yes? Gas and vapor, what is the difference? What is the difference between gas and vapor? What do you think? And will you use? Yes, why not you? Yes. The difference between gas and vapor? Yes. Oh, no, you can't all the time, you can't shake your mouth like this. Like that small children. No, when we just pitchifying order, then what is the difference? What is the difference? Now, normally, how we differentiate gas and vapor, that's important. Now, if I ask you, just think about water. We know water means liquid state of H2O. There is no doubt water means liquid state of H2O. So if I ask you water, it's a liquid. And ice means a solid. That is a solid state of H2O. Now, when we consider any substance, it can be water, it can be argon, it can be iron, any substance, they have three phases: solid, liquid, gas. Best example is water, H2O. Best example is H2O. Solid state of H2O, we call it as ice. Liquid state of H2O, we call it as water. Gaseous state of H2O, we call it as not vapor, but steam. Steam, water. Then just think about this metal, iron. Sometimes we used to think this iron as a solid, but you should understand iron also has liquid phase. Iron also have gaseous phase. But why we used to think iron as a solid? Current room temperature, current existing temperature, that material is as a solid. How we can form iron to liquid? By increasing the temperature. The vapor means gaseous state of. Vapor means gaseous state of any substance. Okay, that is the main important thing. First important thing you want to understand: vapor means gaseous state of any substance. And in this section, we specifically learn about only the water vapor, because when you consider vapor, vapor can be formed due to water. We call water vapor, oil vapor, iron vapor. Likewise, there are many types of vapor, but specifically we talk everything only regarding water vapor. Okay, write down. Vapor means the gaseous state of. Vapor means the gaseous state of any substance. 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 And the properties of water vapor. The properties of water vapor is studied. The properties of water vapor is studied under this section entirely. Under this section entirely. The properties of water vapor is studied under this section entirely. Then we know that what is vapor. Hereafter, always used to think, now we are talking about water vapor. Even though I say water or not, hereafter just think that we are talking about vapor. Water vapor, water vapor. Water vapor means a gas. Gas state of H2O is water vapor. That means steam, water vapor. Now, already I explained how this vapor pressure produces, because it is very similar to it's very similar to gas pressure. Now we can say these are the particles of vapor. These are the particles of water vapor. water vapor. At a certain temperature, we know that all these particles have their unique kinetic energies. And we know that these vapor particles, water vapor particles, undergo continuous collision between the molecules, if not between the particles, and with the container. These water vapor particles undergo continuous collisions between the particles and with the container. As a result, what would happen? As a result, we know that linear momentum of the particles will change definitely. When there is a collision among the particles or with the container, definitely linear momentum will be changed. When there is a change in linear momentum, we know that there should be a force exerted on the particles. Just think about two particles in collision. Whenever there is a change in linear momentum during a collision, there must be a force exerted on them, right? According to, now just think about a particle is colliding with the wall of the container, then definitely linear momentum of this particle changes. That means a force is exerted on the particle according to Newton's third law. Equal and opposite force is exerted on the wall. That means wall undergoes some kind of force, some kind of pressure force. That's how this wave pressure produces. So what you do, first of all, draw this diagram. This diagram quickly. This diagram quickly. This diagram quickly. Write down. Write down. Write down. When vapor molecules, if not, you can use vapor particles. When vapor molecules collide with the wall of the container, when the vapor molecules collide with the wall of the container, the linear momentum of vapor molecules, the linear momentum of vapor molecules, the linear momentum of vapor molecules change. The linear momentum of vapor molecules change. Next point. Next point. As a result, forces are exerted. Forces are exerted. Forces are exerted on the wall. On the wall. Okay. So when those forces continue, when those forces exert on the wall of the container, when those forces exert on the walls of the container, when those forces exert on the wall of the container, container undergoes a certain pressure. 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 This is what we call as vapor pressure in a container. This is what we call as vapor pressure in container. Now, idea is very simple. If you want to understand how this vapor pressure forms, there are vapor particles in the container. Particles collide with each other. As a result, linear momentum of the particle changes. Therefore, there are forces exert on the particles, forces exert on the container. When force is acting on an area, there will be pressure. Because of that pressure, because the pressure we call as vapor pressure, right? We don't need to write any expression for that vapor pressure. No need to write any expression. Then you understood what is vapor pressure, right? Not you understood. Then what you do, put your important points, right? Important points. Now, vapor pressure depends on some factors. Vapor pressure depends on some factors. If you want to increase vapor pressure in a container, by changing these factors, you can increase or decrease vapor pressure in the container. Now, first important point is what would happen for the vapor pressure when temperature changes. Now, currently, this vapor is at a temperature capital T, 20 degrees Celsius. What would happen if I increase the temperature from 20 degrees Celsius to 30 degrees Celsius? What would happen when I increase the temperature? When I increase the temperature, what would happen for the kinetic energy, different velocity of these particles? Because we know that root mean square velocity is directly proportional to root absolute temperature. When temperature increases, velocity of vapor particle increases. When velocity of the vapor particles increases, kinetic energy of the vapor particle increases. Then what would happen? Now, previously, when the temperature was 20 per second, let's say there were only 20 collisions occurring in the container. Previously, at 20 degrees Celsius, every 1 second, there was only 20 collisions occurring in the container. Now, temperature is 30 degrees Celsius. Now, what's happening per second? As their velocities are high, previously velocity was low. Then there were only 20 collisions per second. Now, their particles velocity now is very high. Now, 1 second, number of collisions are high. When number of collisions are high, I say now 50 collisions per second. More collision means more change in any momentum. More change in any momentum means more force means more pressure. So therefore, idea is very clear. Vapor pressure, what vapor pressure increases with the temperature. When we increase the temperature, water vapor pressure increases. When temperature decreases, water vapor pressure decreases. Okay, that is first point. Write down first point. First point. When the temperature is increased, when the temperature is increased, the rate of collisions increases. Therefore, vapor pressure increases. Then understood, first factor which decides the vapor pressure is temperature. Understood? Okay. Now, second factor is volume. Now, this time I'm not changing the volume of the container, same volume. No. This time I'm not changing the temperature. I'm maintaining all remaining factors constant. This time, I'm going to change only the volume of the container. Right? Okay. Now, there are two different containers. We understand this container has a smaller volume. This container has a larger volume. But initially, a certain sample of water vapor is inserted in the smaller container. To understand the certain sample, okay? Now, let's say in that sample, there are 100 molecules. In that certain sample, there are only 100 water vapor molecules. Then I'm going to put the same sample, same 100 water vapor molecules in the second container. Then I'm going to check what would happen for the water vapor pressure. Then we know that if I put same sample, same 100 water vapor molecules in a smaller container, they compact so much, right? Now, rather than putting all of you in this class, if you go to 28, you all are well compact. So then pressure is high. When you compact, more collisions among you, right? This one collide with you, this girl collide intentionally, you hitting a top too. As a result, what will happen? Pressure definitely decreases. When volume is high, you can sit the place that you prefer, but not in my class, other classes. So then number of collisions per second is low linear momentum, low force, low pressure. So therefore we understand vapor pressure depends on volume of the container. When volume of the container increases, vapor pressure decreases. Vapor pressure decreases. Am I correct? When volume of the container decreases, vapor pressure increases. That's the idea. Next point, write down. Next point, write a second point. Now, if you want to write down these diagrams, I don't ask me. It's your responsibility to draw the diagrams and everything. It's up to you. If you feel it's important, it would be better to note down when you are referring. When you are referring in upcoming days, just put them. It's up to you. It's up to you. It's up to you. It's up to you. Write down. Write down. When the volume of the vessel is reduced, when the volume of the vessel is reduced, when the volume of the vessel is reduced, the rate of collisions increases. The rate of collisions increases. The rate of collisions increases. Thus, vapor pressure increases. Thus, vapor pressure increases. Then vapor pressure depends on temperature, volume. What else? Now, this time I'm going to maintain same temperature, same volume of the container. Right? Same volume of the container, same volume. I'm going to maintain same temperature, same volume. I'm going to use the same water vapor. I'm going to use the same water vapor. Water vapor. What is the vapor? Water vapor. Right? Water vapor. But what I'm going to change is I'm going to change the number of water vapor molecules. I'm going to change number of water vapor molecules in those containers. Very clear that number of water vapor molecules in this container, I say N1. Number of water vapor molecules in this container, I say N2. You can clearly see that number of water vapor molecules in this container larger, smaller. Larger number of molecules means larger number of collisions, larger linear momentum, larger pressure. Smaller number of molecule means smaller pressure. Vapor pressure is high, vapor pressure increases with the number of molecules in that container. Okay, next point, write down. Next point, write down. Next point. When more vapor is inserted from outside to the vessel, means we are increasing number of vapor molecules, okay? When more vapor is inserted from outside to the vessel, when more vapor is inserted from outside to the vessel, the number of collisions increases, so vapor pressure increases. Okay, that story done. That story done. Okay. Then what have you learned so far? What have you learned? You learned what is vapor pressure. And specifically, we are talking about water vapor pressure. Then we learn the factors which can change vapor pressure. Temperature, volume, number of molecules. There is one more. Type of the vapor. Next one is type of the vapor. Now I said in the section we are talking about water vapor. But I said there are in other vapors, right? Oil vapor, coconut oil vapor, shampoo vapor, sunsilk vapor. So likewise, we can say many examples of vapors, but we are talking about water vapor. But when the type of material, substance changes, it can also provide some kind of impact. So the last point, when the type of vapor changes, when the type of vapor changes, the mass of molecules changes, the mass of molecules changes, and vapor pressure changes. The mass of molecules changes and vapor pressure changes. Mass of molecules changes and vapor pressure changes. Okay. Right? Okay. Now subtopic vapor pressure. Subtopic vapor density. Subtopic vapor density. Subtopic vapor density. Now there is no difference with density and vapor density. What is vapor density? The mass of vapor per unit volume. That is what we call as vapor density. Density means mass per unit volume. What is vapor density? Mass of vapor per unit volume. Mass per unit volume, mass of vapor per unit volume. Write down vapor density. Under that, write down mass of vapor per unit volume. The mass of vapor per unit volume is defined as vapor density. So then what is the equation? I don't need to teach these things. Vapor density means the vapor density means write down mass of vapor over volume of the vapor. So that means simple density means you can define either rho or simple d. I thought of defining simple d equals mass over volume. Then what is the units of vapor density? Units of density. That means units of mass kilogram, units of volume meter cube. Then units of vapor density means kg m minus 3. Sample question 1 write down. 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 Write down. It's a basic sample question, okay? The mass of water vapor in a container of volume 5 meter cube is 5 grams. 5 meter cube is 5 grams. Find the vapor density. Continue, right? If the volume is increased from 5 meter cube to 10 meter cube, if the volume is increased from 5 meter cube to 10 meter cube, then find the vapor density. Then find the vapor density. Then find the vapor density. Quickly do it. Quickly do it. It's not difficult, right? Where is water? And so today we are writing that 20th paper. So then what we do now, 20 papers we discussed. Did you bring the papers, madam? You brought? How kind. It's a big number of papers. Take the papers, we'll check. 20 papers. It's a big thing, right? No? Small thing? All 20 papers. It's a big achievement for me. Within 20 papers means it took about 5 months. Only this much. How many papers? This much? Okay. So you guys, while doing that sample question, please you guys keep on doing the sample question. Okay? Keep on doing the sample question. Right? 1, 2, 3, 4. Keep on doing, huh? And next week, there is no paper class. It's a holiday. But you know what's my plan? Can someone predict what would be my plan? Next week, there is no paper class. It's a holiday. As we discussed 20 papers, as we came to a round number, so we'll take a holiday. But do you know what's the plan? Here, Layman, discuss this much of papers. You know what's my plan? Any guessing? Tell me, you are guessing. What would be the plan now? Next week there is no paper class. Then what would be the plan? What is the plan? Can you smell that plan? You can smell, right? What is the plan? What is the plan? The plan gonna be class. What class? Class. The plan gonna be. Why not? You can talk. The plan gonna be. Sorry? Wow, great. You have a good smell of identifying some secrets. So what we're gonna do, next Saturday gonna be 2 theory classes. How is that? How do you feel? 2 theory classes. As usual, 8:30 to 1 o'clock we have the theory class. 2 to 7:30 we have the second theory class. You know why? Can someone say why? Why we are having another theory class on upcoming Saturday? Why? Why? Virna? Why? Why we are having another theory class on next week? Why? Last week, right? Last week we didn't do the class, right? That class is doing on next week Saturday. Okay? There's no time. Okay, right? Okay. Now, very easy sample question, right? Very easy sample question. Now they are asking. Now we want to find the vapor density. Now we know the equation. Density means mass over volume. Initially, they mentioned what is the mass of vapor in that container, 5 grams. How can I convert grams to kilograms? 5 into 10 to the power minus 3. Then 5 grams becomes 5 kilograms divided by the volume, 5 meter cube. Then vapor density will be 10 to the power minus 3 kg m minus 3. How many will this answer? You should get this answer. And then further they mentioned, suppose volume of the container is increased from 5 to 10 meter cube, then what would be the density? Now, in that case, Now, volume of the container is increased from 5 to 10. But there is no change in the mass of the vapor. Vapor mass is same as 5 into 10 to the power minus 3. Volume gonna be 10. Then the answer will be 5 into 10 to the power minus 4 kg m minus 3. Correct? Right, okay. Now put your main topic. Now only we are entering into the section saturated. What we call saturated vapor. Saturated vapor. Saturated vapor. Okay. Now today is entirely discussing. It's all about discussion. Okay, today is entirely discussion. I am talking. You have to keep on listening. That's today's job. Okay. Right. Now in chemistry, you might have learned this before, right? When two phases in dynamic equilibrium. Did you learn about that? KPKC, 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 KDO, KA, KDK, KPKC, KD, KA or KD? KD means not that Tamil kid. KD, KD, right? KD. Now, normally, when a container is closed, a closed container having liquid inside, closed container having liquid inside, what would happen? What would happen? Closed container having a liquid, what would happen? This is important. It's important section. Conduction, convection, easy. Thermometry is theory. This is somewhat complex to understand. Because people don't listen to what I'm teaching. That's the problem. They can't keep their focus. That's the problem. Until 1 o'clock, difficult to focus. That's why they don't understand. Other questions, MCQ is also very difficult. Okay. Okay. Now, it's a closed container. Just think about water, liquid is inserted up to a certain volume in the container. Water is inserted up to a certain volume in the container. In the container. Now, what will happen as a result? What will happen? Water means water molecules. As usual, water molecules, they undergo continuous collisions. Right? Water molecules undergo continuous collisions. Like gas. And at a certain temperature. Now, temperature is capital T. Now, what will happen? There are some water molecules. Due to this temperature, some molecules absorb heat energy. That's how we explain this idea. Due to the temperature capital T, some water molecules in the container absorbs heat energy. Absorbs heat energy, breaks intermolecular bonds with other water liquid molecules. Once absorbing the heat energy and once this water molecule, this liquid molecule breaks the bonds together with other liquid molecules, this molecule is free to move. This molecule is free to move. What will happen to this molecule? This molecule will be moving to air. Then it becomes vapor. It becomes vapor. Now, initially, when the moment now, initially it's a closed container and you fill some amount of water. When T equals 0, initially, you could not find any vapor molecules in this region. When T equals 0, you could not find any vapor molecule in this region. With the time, what would happen? Some water molecules initially, some water molecules, liquid molecules, due to the temperature, they absorb heat, breaks the intermolecular bonds. Now they are free to move to this region. Then they will become vapor molecules. they will become wave molecules. Now, this initially converting from liquid to gaseous state, this process happening. Then what would happen to the number of gas molecules, number of wave molecules in this region increases. Number of wave molecules in this region increases initially. This is quickly happening. Quickly happening. Absorbing heat, breaking intermolecular bonds, get into this region. Then initially what will happen? Number of wave molecules in this region increases. Now, one certain number of wave molecules reach in this region, what would happen? Initially, there was no wave molecules in the region. Therefore, more and more wave molecules reach that region. Once there are certain number of wave molecules in that region, what would happen? They collide with each other. Now, when more and more wave molecules in this region, what will happen? Now they start to collide with each other. When these wave molecules collide with each other, what would happen? These wave molecules lose their energy. They had some kind of kinetic energy. Now, due to the collision with the wave molecules, they lose the energy. As a result, what will happen? Again, the wave molecule becomes to the liquid state. You understand? So, what we call this process? Liquid to vapor. We are calling vaporization process. Vapor to liquid, we call it as condensation process. Initially, rate of vaporization very high. After reaching certain number of vapor molecules in that region, now condensation starts. Now vapor becomes liquid again. Now what will happen? Rate of vaporization decreases. Rate of condensation increases. Right? At a certain instant, what will happen? Rate of vaporization and rate of condensation becomes equal. Okay. Then what will happen? Will rate of vaporization and rate of condensation stops? No. Very carefully understand. This is important. How many of you understood up now hands? Do you really understand what I'm saying? Shall I explain again? No need, right? No need, right? Now, let's say when initially 100 liquid molecules became vapor, when t equals 0, every 1 second. Okay. Now, after t equals 5 seconds later, rate of vaporization. Now only 90 liquid molecule becomes vapor. Next second, 80 liquid molecule becomes vapor. In the next second, 50 liquid molecule become vapor. Likewise, other side, that vapor molecules become liquid molecules. Initially with 0, then 10, 20, 40, 50. Vapor to liquid. Then we understand at this instant, rate of vaporization. That means liquid molecules becomes wave molecules. Rate of vaporization and vapor molecule becomes liquid molecule. Rate of condensation becomes equal. This is what we call as dynamic equilibrium. That means even though those two processes occurring, number of molecules existing in liquid and number of molecules existing in vapor remains constant. But still one molecule going to the liquid side, one molecule going to the vapor side continuously, 1 to 1. But overall, liquid and gas phase, overall number of molecules remains constant. This is what we call as dynamic equilibrium. That means rate of condensation and rate of vaporization occurring. But in that relevant gas and liquid region, number of gas molecules and number of liquid molecules same. That's the idea. Okay, you got it? So then what I explained so far, I'll brief it. Shall I brief it? We'll brief it. You need a break right now? No, right? You know what is wave pressure. And we know the factors which can change wave pressure. Now we are talking about some kind of saturated vapor before understanding saturated vapor, you should know that what does it mean by dynamic equilibrium in a liquid and vapor, if not liquid and gas states. Now, you know that initially when there's a container, initially when you fill that container with certain amount of liquid, water, when t equals 0, in that empty space, we could not find any vapor molecules. But with the time, we know that liquid molecules become vapor molecules. Now that empty region is filling with vapor molecules, right? Right after some time later, again vapor molecules start become liquid molecules. The rate of vaporization means liquid molecule becomes vapor molecule. Rate of condensation means vapor molecules become liquid molecule. At a certain instant, those two rates become equal. Rate of vaporization, rate of condensation becomes equal. This is what we call as dynamic equilibrium. Okay. Write down this diagram. What's diagram? This diagram. Write down this as vaporization and mark this as vapor. Vapor, this is liquid. Mark this as condensation. Condensation. Write them quickly. Write them quickly. 9:30. Time is going, ni. Ayo. What? 40,000. No. Well, orange, how can I go home? No, first my wife see the watch, then only she look at me. Okay. So you're hungry? No, right? Okay. Right on. So we'll take a break at now. What is the time? Now time is 9:31. We can take a break at what time? We can take a break at 11, right? That's great. 11. Yes, 11 is right. We can take a break at 11. That's good. That's good, right? That's good because we want to finish this quickly. Want to finish quickly. Now we'll write the story. Now we'll write down. So we'll write the story like this. Write down. Write down. In a closed container containing a liquid. In a closed container containing a liquid. Today it's all about explanation. Today we can't do questions, I think. In a closed container containing a liquid and its vapor. And its vapor in equilibrium. And its vapor in equilibrium. Comma. Molecules are constantly moving between. Molecules are constantly moving between. Molecules are constantly moving between. Moving between. The liquid and vapor phases. The liquid and vapor phases. The liquid and vapor phases. Next point. When a molecule in the liquid phase, when the molecule in a liquid phase when a molecule in a liquid phase gains enough energy. Gains enough energy. When a molecule in a liquid phase gains enough energy, inside the bracket typically from heat, inside the bracket typically from heat, close the bracket. To overcome the intermolecular forces, holding it in the liquid phase, holding it in the liquid phase, holding it in the liquid phase, comma, it evaporates into the vapor phase. It evaporates into the vapor phase. It evaporates into the vapor phase. Full stop. Conversely, when a vapor molecule loses energy, when a vapor molecule loses energy, inside the bracket, such as through collision, inside the bracket, such as, inside the bracket, write down, such as through collisions with other molecules or the container walls. Close the bracket. It condenses back into the liquid phase. When you are writing, understand and write down. Okay, it's your responsibility. I categorize everything and I give the note. You understand and write down. Okay. It condenses back into the liquid phase. Next point. Dynamic equilibrium in saturated vapor refers to a dynamic equilibrium in saturated vapor. Dynamic equilibrium in a saturated vapor refers to a state where the rate of condensation of vapor molecules, back into the liquid phase. I'm very slow, right? Actually, what I asked, we wrote the rate of condensation of vapor molecules back into the liquid phase. Is equal to the rate of vaporization of liquid molecules, liquid molecules into the vapor phase. Highlight dynamic equilibrium, rate of condensation equals rate of vaporization. Right, okay. Now I think you can understand what's happening here. I think you can understand. Right. Right. How many of you cover the section in school and cover the section in school? No. You covered. They don't cover anything, but they give everything in the paper. மனசாட்சி இல்லாத மனுஷங்க தான் என்னத்த சொல்ல. Did we put the topic saturated vapor? Right, okay. Again, we'll put saturated vapor. Again, put the topic saturated vapor. Saturated vapor. It's okay to put the same topic twice. That does not matter. It makes the note beautiful. Saturated vapor and write down. Write down. Blue color pen. If a vapor is in dynamic, red color pen. Red color pen. If a vapor is in dynamic equilibrium, if a vapor is in dynamic equilibrium, comma, no need to put comma, dynamic equilibrium, it's not my fault. You want to tell that you are senior after. It's not my fault. Dynamic equilibrium. He's teaching, right? Now he's also teaching. He's a very bright one. Sometimes I ask doubts from him. Sometimes I get really uncomfortable if I could not answer for him. It's a very genius. He definitely takes 3 years, no doubt. Okay, nice. Okay, leave it. Okay. What is important? Important character, attitude. So do you think, can you see both of them in myself? I don't know how you think about that. But character and attitude can see in that student. I like him. I like him. Right? He will be a good doctor. Good doctor, huh? Not doctor. Good doctor. Very. Yes. What is this life? Okay. What did we write? We wrote that if a vapor is in dynamic equilibrium with its homogeneous liquid, with its homogeneous liquid, with its homogeneous liquid, then that vapor is said to be saturated. Super highlight that, okay? Then that vapor is said to be saturated. Then that vapor is said to be saturated. If a vapor is, no, shall I repeat it? You want me to repeat, right? No? If a vapor is in dynamic equilibrium with its homogeneous liquid, then that vapor is said to be saturated. Now, what you want to know is, actually, you want to know what does it mean by saturated vapor. If you exactly know about saturated vapor only, you can differentiate unsaturated vapor and saturated vapor. Am I correct? In this section, the difficult thing is identifying whether that vapor is saturated or unsaturated. It seems like easy. If you put un in front of saturated, it's unsaturated. But in a question, deciding whether the system is saturated or unsaturated is critical. Then you should know what is saturated vapor. Now, I think I know that when I was explaining about this rate of vaporization, rate of condensation, dynamic equilibrium, mainly you concerned about this liquid. Mainly you thought in the liquid perspective. But hereafter you want to think always this empty region. We are interested only this empty region. So you please always from t equals 0 to, from the beginning, please keep on thinking what could happen to this empty region. Then very clear that I explained when t equals 0, there was a container filled. That instant only I filled that liquid water when t equals 0. Then you noticed when t equals 0, this region is completely empty. You noticed when t equals 0, this region is completely empty. This region is completely empty. So then with the time, what happened with the time? What happened with the time? This region is filled with vapor. With the time, you notice this region is filled with vapor. Then with the time, 1 second, 2 seconds, 5 seconds, 10 seconds, 20 seconds, this region is completely filled with vapor. Now you are keep on observing. You are keep on observing. At a certain instant, because until at a certain instant, what will happen? That empty region gonna fill with vapor molecules. At a certain region, what would happen? At a certain region, what will happen? That region gonna fill with maximum number of vapor molecules. Initially, this region was empty. With the time, this region is gonna fill with vapor molecules. Number of vapor molecules in this region increases. At a certain instant, that region gonna fill with maximum number of vapor molecules. Okay? At a certain instant, this region is gonna fill with maximum number of vapor molecules. Maximum number of vapor molecules. Am I correct? At that certain temperature and that specific volume, because when volume and temperature changes, the number of vapor molecules, maximum number of vapor molecules can be changed. So understand, this is I'm talking for a certain temperature and certain volume. When you consider this capital T temperature and capital V volume, I'm repeating again and again for you to understand, because most of you don't understand. At this temperature, this volume, this region gonna fill with its maximum number of vapor molecules, right? Now this region is filled with maximum number of vapor molecules. Is it possible to have one more vapor molecule to accommodate this region? Can't. Even now this liquid I want to come inside, shall I come inside? This water molecule wants to be a vapor molecule and accommodate this in this region, but can't. All the seats are filled, right? Then we call that this region is saturated. At a certain temperature and volume, if maximum number of vapor molecules fill in that region at that temperature, we say that that region is saturated. No more vapor molecules can be accommodated in that region. Then the vapor in that saturated region we call as saturated vapor. Okay. Okay. Got it? So write down. If a space is saturated with vapor, then the maximum amount of vapor is existed under that considering temperature and volume. If a space is saturated with vapor, then maximum amount of vapor is existed under that considering temperature and volume. I should have given that in red color pen. Can you make it red? Can't. But then we can make it rose or yellow. Use your highlight and make it rose or yellow. Okay. 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 Okay, please go through what you learned up to now so far. From the beginning, please go through what you learned so far. And please be 100%, what is the way that we call adjective for attention? Attentive. Please be 100% attentive and follow what I say. Follow what I say. You are going to follow only for 6 months. 6 months, right? Plan to finish in May, but exam. I said that 3 months before the exam. December exam. September, October, November. September we can finish. December exam. October, no, September, August, end of the August, September, October, November. Huh? November exam. Who said? Now it is announced November. November, okay, that does not matter when they keep exam. That doesn't matter me. You just go through the note and refer it everything. I'm going to ask some cross questions from all of you. That doesn't matter. Exam time doesn't matter, right? You need a break? No need me. Refer it. Go through the note. What you learned so far, please go through it. I'm going to ask some cross questions. I will ask some cross questions. Shall we take a break and come? No need me. How many of you didn't have your breakfast answer? Didn't have your breakfast. So you had your before breakfast something, right? How many of you had your didn't have your breakfast answer? Answer. 1, 2, 3, 4. At what time you need to take your break? At what time you won't have your breakfast? What time? 11. Okay. Right. Okay. Okay. Refer it. Everything refer it quickly. If not, you won't understand the sections. That's what will happen. If you don't follow what I said, this is what will happen. The section is not easy. All about explain. Refer it. So we'll discuss unsaturated vapor and we'll take a break. Not 20 minutes. How long you need? You want to go out and have the meals? No, right? You brought, right? You had the breakfast. Okay? You had. Okay, therefore, not the break, but I need a break. Even you don't need. Okay. Okay. Okay, now stop doing and look at here. Now you know what is saturated vapor. You know that what is saturated vapor. If a volume is at that temperature and volume, this is important. At that temperature and volume, if a space is occupied with its maximum number of molecules, under that temperature. Now I'm highlighting temperature and volume because there's a reason. If a space is under at the temperature and volume, if a space is having its maximum number of molecules, then we call that this region is saturated. This water vapor we call as saturated water vapor. Right, okay? Now, when the temperature is T and when the volume is V, this region is saturated. There is no doubt. What would happen? What would happen by maintaining volume same as V? If I increase the temperature, what would happen? That's my first question. Now temperature is not T, but now temperature is T1. Now temperature T1, but volume is same as V, same volume. Now temperature T1. Same volume. Now temperature T1. Raise your hands. How many of you say at T and V, at capital T temperature and capital V volume, this vapor is saturated? There is no doubt. It's a given data. Now, by maintaining volume same as V, when I increase the temperature T1, now T1 is larger than T. Raise your hands. How many of you say that? How many of you say that? But same number of molecules, huh? How many of you say that when I increase the temperature, how many of you say that now this vapor is saturated, hands up? How many of you say that now this vapor is not saturated, hands up? I'll ask a question. This is the difficult thing. When the temperature is capital T and the volume is capital V, there is a water vapor. At that T temperature and V volume, that water vapor is saturated. What is the meaning of saturated? Under the temperature and under that volume, maximum number of water vapor is inserted. If I change the temperature from T to T1, T1 is larger than T, I am asking, still do you think this water vapor is saturated? How many of you say still the water vapor is saturated, hands up? Still it is saturated, hands up? Still water vapor is saturated, hands up? Still water vapor is saturated, hands up? Still water vapor is not saturated, hands up? Water vapor is not saturated, hands up? Why not saturated? Why? How many of you raise not saturated, hands up? At this T1 temperature, this vapor is not saturated, hands up? Why it's not saturated? Why? Louder. Idea is very clear. Understand. I mentioned at capital T temperature and capital V volume, this vapor is saturated. When the temperature is increased, understand what would happen by maintaining same volume, vapor gonna unsaturated. Okay. The reason is it is proved. It's a experimental result. Saturated vapor pressure, if not maximum number of vapor molecules to saturate, depends on the temperature. When temperature is high, if not when you increase temperature to high values, saturated vapor pressure is high. That means at that certain volume, you can bring more number of molecules. If I explain in detail, let's say now, same volume. There are 3 containers having same volume, V. But temperature maintenance volume is 20 degrees Celsius. Temperature maintained in this volume is 30 degrees Celsius, 40 degrees Celsius. You should understand, when temperature increases, more number of vapor molecules can be brought into the container. If I say Now, all these three containers saturated. We'll see in that way. All these three containers saturated, but when temperature high, even though same volume, larger temperature means larger number of wave molecules. If I say here number of wave molecules 100, number of molecules wave molecules 200, number of wave molecules 300. Anyways, I will brief it. Understand, it's a experimental result. When temperature is high, saturated wave pressure is high. That means when you increase the temperature in that volume, we can maintain more number of water molecules. Do you understand? At 20 degrees Celsius, if this container is saturated, number of molecules will be 100. At 30 degrees Celsius, if in order to saturate the vapor, you require 200 molecules. At 40 degrees Celsius, if you want to saturate this vapor, there should be 300 molecules. Now, I say at capital T temperature, I mentioned this capital V volume is saturated. I say required number of molecules to saturation is 200 for T Celsius. When temperature increase means in order to saturate this region, it requires 300 molecules. But how many number of molecules existing here? 200 molecules. Under this temperature, we can accommodate 300 vapor molecules, but currently there are only 200 molecules. Then do you think this region is saturated? No, not saturated. Okay. You understand what I'm saying? Okay. I will explain what will happen when temperature decreases later. You got it? The next important, raise your hand, someone if you understand what I'm saying. Understand what I'm saying? I'm in the interval, I'm going to cross-check that. The next thing is what would happen when volume decreases. Now you know that for a given temperature, saturated water vapor amount is constant. Am I correct? At 20 degrees Celsius, if you want saturated region, you require 200. At 30 degrees Celsius, if you want to saturate a region, you require 300. That type of idea. Now what I'm doing at capital T temperature and capital V volume, this region is saturated. What would happen if I increase the volume by maintaining same temperature? Now I'm going to increase the volume. Now volume gonna be V2. V2 is larger than initial volume. My question is, by maintaining same temperature, if I increase the volume, raise your hands, how many of you say this vapor is saturated, hands up? How many of you say this vapor is saturated, hands up? Not saturated, hands up. You're confusing, right? Is it confusing? How many of you feeling confusing, hands up? If it is hands up, how many of you feeling confusing? Hands up, hands up, hands up, hands up. I'll ask the question again. I think you mistaken my English. My English. This is difficult. This section is difficult. My question is, at capital T temperature and capital V volume, this water vapor is saturated. What is the meaning? That means under this temperature and volume, maximum number of water molecules exist in here. Again, I ask the question, at capital T temperature and capital V volume, this vapor is saturated. My question is, if I increase the volume by maintaining same temperature, how many of you say this region is saturated, hands up? Not saturated, hands up. Not saturated, hands up. Not saturated, hands up. Why not saturated? Okay, I will say like this. At capital T temperature and capital V volume. At capital T temperature inside capital V volume. At capital T temperature inside capital V volume, I say we can accommodate maximum 100 molecules. And then there are 100 vapor molecules in this container. Now I say same temperature, but volume is, I say that volume V2 equals 2V. Now volume is twice the previous volume. Okay. Now volume is larger volume. The volume is larger volume. My question is, raise your hands. How many of you say now this vapor, now this region is saturated, hands up? It's not saturated, hands up. Because why? Same temperature, but volume became twice. Under the temperature, if you have one bus, you can accommodate 200, 100. Under, if you have one bus, under the temperature, you can accommodate 100. If you have two buses, you can accommodate 200. Even though you have a potential of accommodating 200 molecules, currently existing 100 molecules. It can accommodate 200 at that temperature and volume, but currently available 100. Do you think this vapor, if this region is saturated? No, unsaturated. Then you understand the idea is number of saturated vapor molecules. Okay, every point is important. Number of saturated vapor molecules depends on temperature and volume. Okay, so we'll write a point right down. Write a point. Red color pen. As the volume and temperature increases, this is really difficult section. That's the problem. Okay, it's really difficult to understand what is saturated or it's not saturated. That's the problem. As the volume and temperature increases, anyways, at the end I will summarize it, then you can understand. The maximum amount of vapor that can be existed in a given space. Also increases. Red color pen important. Vapor pressure and vapor density are maximum. Vapor pressure and vapor density are maximum when the vapor is saturated. That is easy. Now let's say now under this temperature and volume, if this region is saturated, means maximum number of molecules exist in this volume. Okay, if I say that under capital T temperature and capital V volume, if this region is saturated, means we know that maximum number of molecules existing in this region. If this region occupies maximum number of molecules, means what? Maximum number of vapor molecules means we know that pressure is maximum, because I explained vapor pressure depends on number of molecules in that region. If this region occupies its maximum number of molecules, then we know pressure should be maximum. Next thing is, if this region occupies at the temperature and volume maximum number of molecules, mass in this region is maximum. Even though volume is a constant, when mass is maximum, vapor density is maximum. you understand what I'm saying? So therefore, if a region is saturated, there is no doubt pressure is maximum, density is maximum. Okay. We'll take a small break and come. 10, 10. 10, 10. How long in the break? 15 minutes? Is it possible? Why not? We'll have 3 minutes and come. 15 minutes, 15. Then we'll have another break at 10 minute to 5 minute break at the end. Time is 10, 10. Come at 10:25. Sometimes I'm come at 10:25. Yes. You calmly, you go when you have your breakfast and come. There is no restriction. But I keep on teaching. It's okay. Right. Take your break and come. Come at 10:25. What happened when every Okay, right. Okay. Now we understand what is saturated vapor. Now we understand what is saturated vapor. Saturated vapor. Right? I'm not going to explain about what is saturated vapor. You understood what is that. Okay. Now, if a region is saturated, I would say that just take this volume. When you take this volume, let's say under this temperature, okay, and volume, this region is saturated. That means this region is filled with maximum number of water vapor molecules. If this region is saturated, this region contains maximum number of water vapor molecules. Saturation can be identified by another different way. Saturated. That means contains maximum number of water vapor molecules. Contains maximum number of water vapor molecules. Contains maximum water vapor molecules. Now, let's say that I will say at this temperature, at this capital T temperature, and let's say at this volume, because you know saturated vapor pressure or saturated maximum number of molecules to be saturated depends on temperature and volume. Now we understood maximum number of saturated vapor molecules depends on temperature and volume. I will say at this temperature and volume, maximum number of water vapor molecules will be 100. At this temperature and volume, maximum number of water molecules will be, I say, 100. For our understanding, 100. Maximum number of molecules. Maximum number of molecules, 100. Now, if I say this region is saturated, there is no doubt 100 water vapor molecules in this region, there is no doubt. But how do we identify? Now, in practically, if I give you whether this region is saturated or not, by looking at that space or region, how can we identify that whether this region is saturated or not? That's a big concern. Now, okay, now If I say this region is saturated, you understand now it is saturated and you can keep on doing the question. But how do you identify whether a region is saturated or not? That is big question. Now, what will happen? Now you are inserting. Now let's say initially this region is empty. Now you are increasing number of gas. Initially this region is empty. We are adding vapor molecules. And I'm keep on increasing. I'm keep on adding water vapor molecules to this region. Once number of water vapor molecules becomes 100, it becomes saturated. But still I can't identify, even though now it is filled 100 molecules in this region, I can't identify whether this region is saturated or not. So therefore, I don't know, because my target is to obtain a saturated region. I was keep on adding number of vapor molecules. Currently, there are exactly 100 water vapor molecules. But I don't know whether it's saturated or not. So therefore, I'm keep on adding water vapor molecules continuously. Externally, I'm keep on adding water vapor molecules. Let's say now exactly there are 100 water vapor molecules. Therefore, we know that it is saturated. But I am keep on adding more and more water vapor molecules. My question is, once this region is saturated, that means once this region is filled with its maximum number of molecules, what would happen for the remaining vapor molecules that we are adding to the container? No matter you add or you don't add, if it is saturated, only 100 is possible. At the temperature and volume, we can keep only 100 water vapor molecules. But still I am keep on adding. But still I am adding externally by putting a force or something, by pressurizing or something, I don't know. I am keep on adding more and more vapor molecules. My question is, what would happen for those molecules that I'm adding beyond this 100? Once it is filled with 100 molecules, what would happen for the remaining vapor molecules that I'm adding? It's gonna undergo phase change. All the additional vapor molecules becomes liquid and deposit at the bottom of the container. Let's say additionally, in addition to 100 molecules, I added 10 more to the container. Then those 10 molecules will be in liquid state. That's the idea. Now I am keep on adding 1,000 more. Already 100 is filled in the container, but I added additionally 1,000. All those 1,000 molecules will be deposited as liquid phase. So then how many molecules is liquid phase? 1,000. Do you understand? Then my question is, how do we identify whether a region is saturated or not saturated? Whenever you see that empty region is in contact with a liquid, there is no doubt that region is saturated. You got it? In a question, if they mention that container, it is observed some kind of liquid at the bottom, there is no doubt we can say that region, that empty region is saturated. Okay. So therefore, now you know that idea. Okay. So what you do, now in this diagram, at capital T temperature and capital V volume, 100 wave molecules are there. Then we say that saturation as just saturation. So now exactly if a region obtains that 100 molecules, we say it is saturated. It is just saturated. Just now only saturated. So therefore we say that whenever you can't identify any liquid at the bottom, and if it is saturated, we call this as just saturated region. Just saturated. Just saturated. Whenever you identify kind of liquid at the bottom, we say it is saturated. There's a reason behind mentioning just saturated. I will tell you later. When doing questions, it will be important. So we say this, same temperature volume, same temperature volume, saturated. Saturated. Okay. I think you understood now this idea. Then already explained idea, again I will explain. If a region is saturated, okay, I'm talking, if a region is saturated, number of vapor molecules. If a region is saturated, number of vapor molecules, that means maximum number of vapor molecules in that region depends on two factors. I'm talking number of vapor molecules. If this region is saturated, it's really difficult explanation. If this region is saturated, number of vapor molecules, that means maximum number of vapor molecules. Depends on two factors. One is volume of the container, other one is temperature. Okay, one is volume of the container, other one is temperature. Okay, so this is what I explained before. Now, when you consider this volume, example is there are two containers, same temperature, but volume is different, V and 2V. Then both are saturated. Then number of molecules in this container, I say N1. Number of molecules in this container, I say N2. There is no doubt that N2 going to be large. When there are two equal volumes, but temperature different T1, T2, T2 going to be larger. If I consider maximum number of molecules in this container, I say N1. Number of molecules in this container, I say N2. You know that definitely N2 going to be large. Did you really understand this one and this one answer? If you understood this one, then you can do questions. You understood. There's no doubt, right? We'll take a break, another break at 12 o'clock. But keep your attention. Now, write down these two cases. All these things. Nicely write down. Nicely write down. This section is really difficult section. Sometimes, I don't know, sometimes you might feel like you understood, but that is not 100% correct. But it's really good you feel that you understood. Because many people who learn this section, they don't even feel they understood. I also felt the same way. Therefore, is Nescafe? Nescafe. Good, healthy. Nescafe is healthy to drink. So when you break the iftar, always break with Milo. Right. So there is malt, right? Malt and cocoa. It's really good to health. And I would say that now, you know that now. So you can go for big salaries. If you are working as an engineer, it's okay. HR side or accounting side or whatever, you can go for very high salaries in Nestle. Right? Unlimited fuel, they provide. They provide, if you work there more than 1.5 years, they provide the vehicle. And house loan facilities, they arrange. And your salary, you can take beyond 3 lakhs. Currently, it's a big salary, addition to that benefits. So therefore, in case if you are planning, I think when you go abroad, you can earn more than that. But according to country's salary expectation levels, that is really considerably high. Good food, good life. Okay, just jokes. Oh. Quickly, finish writing. Then we can start saturated vapor pressure. Then we can do questions. If you understood until here, that's it. No, not that's it. Still, there are many things to go. So we'll take a break again at 12 o'clock. 5-minute or 10-minute break. Then we are doing until 1. Then paper will be written from 2 to 3:40. 10 questions to be discussed in last paper. Oh. So keep now once you finish writing here, we'll write a small point. Shall we? Let a small point write down like this. If vapor is saturated, red color pen, if vapor is saturated here, if vapor is saturated, today it's all about discussion, okay? We don't do questions. If vapor is saturated, it is in contact with its own liquid. It is in contact with its homogeneous liquid. It is in contact with its homogeneous liquid. It is in contact with its homogeneous liquid. But then write these two as a note. If you finish writing, tell me, then we are going with next topic, saturated vapor pressure. We will do 1-2 questions and we'll come back to the graphs again. What is this life? We didn't write down what is unsaturated vapor. We'll write down that. Still, we didn't write an equation set, right? It's all about theory. It's not theory, but how many pages we did so far? 1, 2, 3, 4 pages. 4 pages. Okay, time is enough, right? Now we'll write down topic. I think this topic will be, I think it should be, and it will be unsaturated vapor, I think. Yes. Put your topic. Unsaturated vapor. Now you can understand what is the difference between saturated and unsaturated. Now you understood until now at this volume temperature, until this space occupies maximum number of molecules, and after that, until space occupies maximum number of molecules, and after that, existing vapor is unsaturated. Okay. If we take this container at the temperature and volume, I told you maximum number of molecules will be 100. Right now, from zero number of vapor molecules to until this vapor is occupying, until this space, this vapor is occupying, until this vapor is occupying 100 molecules in the space, all these vapor we call as unsaturated. Am I correct? Very, very clear. If you understood what is saturated, understanding unsaturated is not difficult. If a space is yet not filled with maximum number of molecules, that space is unsaturated. If a space is not yet filled with its maximum number of vapor, that space is unsaturated. If that space is filled with its maximum number of vapor, that is saturated. That's it. Write down, another topic, write down. Under certain temperature and volume, under certain temperature and volume, if a space is not filled with, its possible maximum number of wave molecules. It's possible maximum number of wave molecules. Then that region or the vapor, then that region or the vapor, then that region or that vapor, whatever, then that region, then that vapor is called as unsaturated vapor. Is called as unsaturated vapor. Unsaturated vapor. Okay. So that is also done. Now main topic, saturated vapor pressure. Now this is the main topic, saturated vapor pressure. Main topic, saturated vapor pressure. Main topic, saturated vapor pressure. Inside the bracket, notation is, there's a specific notation for that. Capital P stands for pressure. Saturated vapor pressure means P naught. Inside the bracket, P naught. Inside the bracket, P naught. Write down definition. Write down. Red color pens, okay. If a space is saturated under given temperature and volume, if a space is saturated under given temperature and volume, if a space is saturated under given temperature and volume, the pressure of that vapor, the pressure of that vapor is called as saturated vapor pressure. Is called as saturated vapor pressure. Is called as saturated vapor pressure. Highlight space saturated temperature. Space saturated temperature, pressure. I'll ask a question. Now again, there will be some kind of confusion with the, when a region is saturated, when a region is confused, that's the problem. When a region is saturated, when the region is saturated, maximum number of molecules, I explained, depends on two factors, volume and temperature. If a region is saturated, maximum number of vapor molecules existing in that region depends on two factors, temperature and volume. If a region is saturated, what is saturated vapor pressure? When that region is saturated, pressure is what we call as saturated vapor pressure. I'll ask a question. Saturated vapor pressure depends on how many factors? If a region is saturated, the maximum number of vapor molecules depends on two factors, temperature and volume. If a region is saturated, saturated vapor pressure depends on how many factors? How many? 4. How many? How many? 3. What are those 3? Temperature, volume, number of particles. Okay, you? How many? 4. Till those 4. Volume, temperature, mass, something else. Again 2. This is important. This is important. Focus very carefully. If a region is saturated vapor pressure depends on two factors. If a region is saturated, maximum number of vapor molecules existing in that region depends on two factors, volume and temperature. Here, if a region is saturated vapor pressure depends on two factors, temperature definitely, and type of vapor. What is the conclusion from those two comparisons? Maximum, if a region is saturated, maximum number of molecules existing in that region depends on volume and temperature. Saturated pressure depends on temperature and type of vapor. What is the conclusion? Saturated vapor pressure does not depend on the volume, only the temperature. Now we are talking about water vapor. We are talking about water vapor. Therefore, we don't think about type of vapor also. Hereafter, think that saturated vapor pressure always depends on one factor, that is temperature. But if you want to find the maximum number of saturated vapor molecules, depends on two factors. Okay. Write down. Saturated vapor pressure depends on two factors. Saturated vapor pressure depends on two factors. Number 1, temperature. Number 2, type of vapor. Type of vapor. Write down a point. As throughout the session, the properties of water vapor is studied. As throughout the session, the properties of water vapor is studied. Normally, we talk about water vapor. Water vapor is studied. We can consider saturated vapor pressure depends only on temperature. We can consider saturated vapor pressure depends only on temperature. Okay. You will understand. Now put case 1. Case 1. Now put case 1. Case 1. Put case 1. Now there are two containers. There are two containers. There are two containers. I say volume of those two containers VV. This is container 1, container 2. Volume of this container is also V. This container also V. But temperature of this container I say T1. Temperature of this container I say T2. Let's say T2 is larger than T1. Now T2 temperature is larger than T1 temperature. Okay. I say saturated vapor pressure for this container 1 is P01. Saturated pressure for the case 2 is P02. How many of you say P02 is larger than P01? Hands. My question is same volume, different temperatures. T2 is larger than T1. Raise your hands. How many of you say P2 is larger than P1? Hands. Previously I asked P2 same in P1. How many of you say P2 is equal to P1? Larger temperature means there is no doubt. Larger pressure. Smaller temperature means no doubt. Smaller saturated vibration. So therefore, there is no doubt we can say saturated pressure at second container is larger. Larger. I say maximum number of vapor molecules in this region. In this region existing. If it is saturated means maximum number of molecules in N1, N max 1 or N1, N2. How many of you say that N2 is larger than N1? Answer. How many of you say N2 is larger than N1? Very careful, huh? Very carefully answer it. Okay, can't sleep anyone. You took the break, can't sleep, huh? How many of you say N2 is larger than N1? Answer. N2 is larger than N1. Again, raise your hands. How many of you can say N2 is larger than N1? Yes, N2 is larger than N1. That is case 1. Write down quickly. Now, when you are writing, okay, write down. Okay. If not, you can write down. Okay, write down. Now, write down P naught means saturated pressure. N means maximum number of molecules. N means maximum number of molecules. Maximum number of molecules. P naught means saturated pressure. N means maximum number of molecules. Quickly. Then put your case 2. So don't worry. I explain properly, but you keep your focus. If you feel sleepy, you go down and wash your face and come. Go down, wash your face and come. Drink by Nescafe, Nestea, cardamom, whatever you want. Go down and wash your face and come. Oh, what? Oh. Oh, okay. Nallador Kudumam, Nallador Kanavan, Nallador Mane, Nallador Kanavan. Case number 2. Case number 2. The raise do you want me to write, give a note regarding this explaining? Raise your hands. How many of you want me to give a note by explaining what's happening here? How many of you don't want answer? How many of you don't want? No, you have to come with an answer. How many of you want me to give a note regarding this answer? No need a note, hands up. I don't mind. Do whatever you want. Case number 2. Case number 2. Now in case number 2, again same two containers. Again same two containers. What is common? Their volumes equal. Temperature equal. Let's say both are saturated. Both are saturated. Container 1, container 2. Let's say saturated temperature at container 1 is P01. Saturated temperature at container 2, let's say P02. Maximum number of molecules N1, N2. How many of you say that P02 is larger than P01, hands up? P02 is smaller than P01, hands up? P0 equals, P01 equals, P02, hands up? Same temperature means there is no doubt. Don't think about V. Saturated pressure, don't think about V, think about only T. When T and T equal, P and P equal. T and T equal, P and P equal. Okay, P01 equals P02. What can we say about N1 and N2? How many of you say N1 equals N2, hands up? Yes. T and T, V and V. VV, TT. If VV equal to T equals, N1 equals N2. If you understand, means the way that I explained is good, right? Case number 2. Next one, case number 3. Write down. Write down. Then we can do some questions. Okay, if you understand, we can start doing the questions. So next week we can finish this chapter. Then we can start convection, conduction. It's a small section. In thermodynamics is there. 2, 3, 4, 5 finish means remaining can be finished easily. 2, 3, 4. 2, 3, 4 is main 3 chapters. Case number 3. Again, 2 containers. Again, 2 containers. Again, 2 containers. Now, what is common? Temperature same. Volume V1. This volume I say V2. Now, V2 is larger than V1. If not, I say V1 is larger than V2. Absolute, not absolute. Saturated pressure container 1, saturated pressure container 2. A maximum number of molecules in container 1 in 1, maximum number of molecules in container 2 in 2. Container 1, container 2. Now I'll ask a question from you. My question from you is, now there are 2 containers, 1 and 2. Temperature same, but volumes are different. V2 is smaller than V1. My question from you is, do you think P02 is larger than P01? Do you think P02 smaller than P01? P02 is smaller than P01. That is what you said. You agree with him? You are angry with him. Why you are not agree with him? As temperature is same, I explained saturated pressure. As temperature is same, saturated pressure only depends on temperature. Therefore, P01 must be equal to P02. So P01 must be equal to P02. This is the problem. Same thing I'm going to ask from you. Do you think N1 equals N2? Yes, right? Do you think N1 equals N2? Do you think N1 equals N2 now? You don't think? No, you don't think. Then what do you think? N1 is larger than N2. How many of you say N1 is larger than N2? Even though temperature same, I explained maximum number of molecules depends on temperature and volume. Temperature same, but volume different. Larger volume have larger N. Larger volume is V1. Therefore, N1 is larger than N2. This is the problem, okay? The problem. Now, theory finish. This is something additional thing to make you more understand what you are doing. Case number 4. This is your problem. This is your problem. Right? So keep your focus. Put your 100%. Ne? Finish. Ne? Finish. Very sleepy, right? Sleepy. Don't Deepika say anything. When will she leave? No. Alatiyappa. No, he young, right? Ask you opportunity for us and ask them to leave. Don't tell her, please. Don't tell her. I don't mind even telling her. Yes, I like her. Her smile is so cute, right? When she smiles. I mean, deep. Every time, every day criticizing others, what we get, we don't get anything right. What we get, some kind of poor mentality. Our mentality is really weak, actually. My, very poor mentality, right? What we get by criticizing someone. Every day I tell to myself, don't do such bullshit things. But that's it. Okay. Case number 4. Okay. Case number 4. Case number 4. Now I don't give a note. Actually, I gave a note for last year people, but as you requested, you don't want to give a note. I don't give a note. Every case I explained and I gave a note. But you don't want to have a note, therefore I don't give a note. So therefore I don't mind. Case number 4. Case number 4. Even though you don't want something, say yes, I want. Get everything. If you don't want later, you can give to another one or someone else. Right? Like Nombo Adia. Right. Next one, case number 4. Case number 4. I'll ask a question. Now this time, again 2 containers. 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 Okay, again it's okay, fine. Same temperature, same volume. But here, no, normally we talk about water vapor. But here this is water vapor. That is oil vapor. Normally it's not. Normally we don't mind about that. Water vapor. This is oil vapor. Oil vapor. Absolute temperature P01, P02, N1, N2. Okay. P01, P02, N1, N2. Okay. Right? How many of you say P0? No, same temperature, same volume. How many of you say? Sorry? How many of you say P01 equals P02 answer? P01 not equals P02 answer? No doubt, me. P01 not equals P02. N01 equals N02 answer. N01 equals N02. Sorry, N1 equals N2. Hands, how many of you say N1 equals N2 answer? Not equal answer. How many of you say N1 equals N2 hands up? Why N1 equals N2? But they are different. I told you, I explained everything considering only water vapor. So not different. Okay. Okay. Case number 4 is done. Okay. Quick. Then we'll do one last case and we'll finish this and we'll start with question. Last case. Case 5. Last case. Case 5 going to be last case. Case 5 going to be last case. Okay. Then we'll finish the story. Then we can start doing 1, 2 questions. 12 o'clock, we'll take a small break of 10 minutes. We are stopping the class at 1 o'clock. Last case, case number 5. Case number 5. Again, this time, this volume is, I say V. This volume, I say 2V. This temperature, I say T. This temperature, I will say 2T. Then P01, P02, N1, N2. We know that now. When you compare these two, volume and temperature larger in this container. So therefore, we know that P02 definitely larger than P01. Why temperature is T? Temperature is 2T. Larger temperature means larger saturated vapor pressure. Therefore, P02 is larger than P01. That is okay. Then temperature is also larger for this container. Volume is also large in this container. Volume and temperature both are large in this container. Therefore, without any 2 doubts, without any 3 doubts or 4 doubts, large. Without any doubts, larger. Right? It's large. Okay, that's what I want to say. It's larger. It's larger. Okay. Story finished. Thank God. Finished, ne? But I didn't give a note for these things, but I don't mind because we didn't want to have a note. Okay, story finished. Now we can summary. We will summarize it. What we learned until now, we'll summarize it. Okay. Now, briefly, what you want to know actually throughout this 1 or 1.5 hour or 2 hour session, what to be understood at the end. That is important. Okay, summary, write down summary. This is a summary you want to write down. Summary. Summary. Write down summary. Saturated vapor pressure. Saturated vapor. Just saturated and saturated. Just saturated. You want to know about this? Just saturated. You know what is just saturated? I'm not going to explain what is just saturated. Next thing, saturated. Just saturated. Next thing you should understand, maximum, I'm talking about water molecules mainly, maximum number of molecules, maximum number of water vapor, maximum number of vapor. Depends on, mainly is water vapor, huh? Depends on volume and temperature. Saturated vapor pressure. Only depends on temperature If it is water, only temperature, but type also. Type. The summary. Right on. Now only the most important point to be discussed. Now you know in this summary that is also including this important point is also including the summary. Now we talked about two types of vapor: saturated vapor, unsaturated vapor. Saturated vapor, unsaturated vapor, unsaturated vapor. Okay. Okay. What is the main difference between saturated and unsaturated vapor? You know the reason, you know the main difference. Remember, understand this important idea. We learned about gas laws. Boyle's law, Charles' law, pressure law, that law, this law. All the laws, all the gas laws can apply it for the. How many of you say we can apply gas law for saturated vapor? How many of you say we can apply gas laws for unsaturated vapor? How many of you say we can apply for both? How many of you say we can apply for both? How many of you say that we can apply all the gas laws for saturated vapor? If you say we can apply gas laws for saturated vapor, raise your hands. We can apply gas laws for unsaturated vapor, hands. Unsaturated vapor, we can apply gas laws. I will explain the reason later. I can explain. Okay. Gas laws can't apply. Got it. Include disease also in your summary. Important. Gas laws can be applied. Gas laws can't be applied. If you cannot obey gas laws, does not obey gas laws, whatever. So we'll do one question. We'll try to understand what's happening here. We'll do a question. And we'll try to understand. So we'll do a question and we'll try to understand. Okay, question. Sample question 1. It seems like sample question, but it's somewhat good question. Okay. Normally sample questions are just sample questions. But this sample question is not sample, more than a sample. Write down the temperature of a mixture. The temperature of a mixture. The temperature of a mixture of air and water vapor. Air and water vapor, right? Understand that air and water vapor. In a sealed container is 7 degrees Celsius. And 7 degrees Celsius in a sealed container is 7 degrees Celsius, and total pressure is 780 mercury millimeters. Total pressure is 780 mercury millimeters. Full stop. When the temperature of the mixture rises to, when the temperature of the mixture rises to 27 degrees Celsius, 27 degrees Celsius, Find the new value of its total pressure. 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 Inside the bracket, write down. Inside the bracket, write down. Inside the bracket, write down. Saturated vapor pressure of water is 28 mercury millimeter. Now you don't write down saturated water pressure, don't write like that. P naught water. P naught water. Saturated water. Saturated water. Saturated vapor pressure of water is 28 mercury millimeters at 27 degrees Celsius. At 27 degrees Celsius, saturated water vapor pressure. That is how much? 28 mercury millimeters. 28 mercury millimeters. And 12 mercury millimeters at 7 degrees Celsius. 12 mercury millimeters at 7 degrees Celsius. Now you know the idea. Now you understood very clearly. You understood. Whenever water is in contact with that, in that vessel, if you notice, there is water. What is the conclusion? Water vapor is saturated. Whenever you notice that container has some kind of water, there is no doubt that vapor is saturated. If there is saturated vapor, we can't apply gas laws for saturated vapor. Pressure of saturated vapor is always saturated vapor pressure. Very, very easy idea, very easy approach. Very easy approach. I want all of you to get the answer. I'm instructing you. Look here. If there is water, or if you feel that vapor is saturated, we can't apply gas laws for saturated vapor. And we know that if there is saturated vapor, pressure is always saturated vapor pressure. We know saturated vapor pressure changes with the temperature. That's why they have given corresponding saturated vapor pressures at 7 and 27. Now, if they have given total this time in that container, there are two types of gases. One is air, one is water vapor. At 7 degrees Celsius, they have given total pressure is how much? 280. Total pressure is how much? 780. If I ask you, if you carefully, if you read the question, you can answer my question. At 7 degrees Celsius, total pressure, that means air plus water vapor, total pressure is 780. What is the pressure produced by only water vapor at 7 degrees Celsius? How much? 12. 12. There is no doubt. Saturated vapor. Then what is the pressure produced only by air at 7 degrees Celsius? 780 minus 12. 768. Air means we can apply gas laws for air, right? We can't apply gas laws for saturated vapor. So why you can't apply suitable gas law and why you can't find the pressure produced by air at 27? So once you found pressure produced by air at 27, in order to find total pressure, it is all about adding what? Once you found pressure produced by air at 27 degrees Celsius, if you want to find the total pressure, it's all about adding 28. Now, can you do the question? Because I did the question so far. You have nothing to do. You only want to copy and write. Will you do it? Get the answer? I'll give 5 minutes. Get the answer? Get the answer? Now we can do questions. Then until 1 o'clock, we'll do questions. We'll do questions. Where the skies are blue, see you once again. Over seas to coast. Nothing gonna change my love for you. How much I love you. Still feels like the first time together. கொடுமை தாங்க முடியல இத்தனை நினைக்கிறீங்க பேசாம கொண்டுடுவோமா is that what you say ஐயோ ஐயோ how many of you got the answer? Got the answer? Got the answer? And sometimes did anyone had a doubt how I came to a conclusion that that water vapor is saturated in both the containers? Hands up, if you got a doubt like that. In the question, one thing also to be written inside the bracket, write down consider water vapor is saturated at both temperatures. Okay? Okay? You should ask such questions from me. Intentionally, I skip that. Instead, bracket, write down consider water vapor is saturated at both temperatures. So I am not only one asking questions. Why you can't ask questions? You are afraid of asking questions? I don't think so. Okay, now I'm also going to do, right? 2 containers. There are 2 containers. There are 2 containers, same or not 2 containers, same container. Now think, now there are 2 substances, air, water vapor. Air, water vapor. Air and water vapor. Now this container is at a temperature of 7 degrees Celsius. 7 degrees Celsius. What is the total pressure produced by the system? Air plus water vapor. Total pressure at 7 degrees Celsius, how much? They have given 780 mercury millimeters total pressure. I say total pressure as PT1. Total pressure PT1. Total pressure PT1. PT1 is how much? Total pressure PT1 is how much? 780 mercury millimeters. As they clearly mentioned, water vapor is saturated at this temperature. There is no doubt. Pressure of water vapor. Pressure of water vapor is saturated water pressure. Pressure of water vapor is saturated water pressure. Red color important, write down. Red color important, write down. As it is mentioned, water vapor is saturated. As it is mentioned, water vapor is saturated at 7 degree and 27 degrees Celsius. At 7 degree and 27 degrees Celsius, water vapor pressure equals to corresponding saturated water vapor pressures. Water vapor pressure equals to corresponding saturated water vapor pressures. Now understand one thing, water vapor pressure and saturated vapor pressure, two different things. Huh? Vapor pressure means common term, pressure for a vapor. Saturated vapor pressure means relevant to saturation. But in this case, they mentioned water is saturated. Therefore, we can say water vapor pressure equals saturated water vapor pressure. Then I say pressure produced by air. Pressure produced by air is how much? I say just P1. At 7 degrees Celsius, pressure produced by only air is, I say P1. How can I find P1? Total pressure 780, pressure produced by water vapor 12. If I want to find P1, I know that PT1 must be equal to P1 plus P01. PT 780. I want to find P1 actually. Plus 12, my P1 will be, pressure produced by air, 780 minus 12, 768 mercury millimeters. If I know pressure of air at 7 degrees Celsius, I can apply gas laws and I can find pressure of air at 27 degrees Celsius. I say pressure of air at 27 degrees Celsius P2. Pressure of air at 27 degrees Celsius, I say P2. I say P2. I can apply what law? I know temperature. I know pressure of air at 17. Want to find 27. What is the law? Boyle law, Charles law. Pressure law. What law? Boyle law. P1 over T1 is Boyle law, right? P1, V1 is Boyle law. Boyle, this is pressure law. Pressure law, right? Pressure. Yes, you can use combined gas law. If not PV equals nRT, that's fine. It's pressure law, right? P1 over T1 equals P2 over T2, pressure law. Pressure law, yes. You thought I can't remember? You thought like that? Yes, I can't remember actually. P1 over T1 equals P2 over T2. Pressure law. Now P1 means pressure of air at 7 degrees Celsius. That is how much? 768. T1 how much? T1 temperature 7 means in kelvins. In how do you convert 7 degrees Celsius in kelvins? 273 plus 7 is 280. I want to find pressure of air at 27 degrees Celsius. I don't know, it's P2. Ayo. 273 plus 27 means 300. Therefore, my P2 will be 768, 280, 300. That is my P2. What is the value? What is the value? How much? How much? 8. 850.8. 850.8. 8. 880. 850. You also told 850 something. 850 point. I don't trust anyone. So I'm going with this answer. Yes, 850 point. 822.8. என்ன பண்ணுவோம்? ஏவா நல்ல விளங்குது உங்களுக்கு. நான் P2 தானேவா பாக்குறேன் நான். ஓகே, என்னவா பிரச்சனை உங்களுக்கு? 822.8. 822.8. But my question, I want to find the total pressure. Total pressure means air plus water vapor pressure. What is the water vapor pressure at 27 degrees Celsius? Water was saturated. Therefore, water vapor pressure means saturated water vapor pressure at 27 degrees Celsius. That is how much? 28 mercury millimeters. So P02 will be 28 mercury millimeters. Therefore, I can get the final answer easily. Total pressure means, therefore, total pressure. Therefore, total pressure, I say total pressure means PT2. That is equal to what? That is equal to P2 plus P02. P2 plus P02. What is my P2? P2 I found 822 plus what is P02? P02 is 28. Then it will be equal to how much? 850. 850.8 mercury millimeters. Raise your hands if you got this answer. Hands up. If you got this answer, hands up. Then if you got this answer, then you understood what I explained. Then I think you understood what I explained. Right? Okay. 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 Then what we can do? Then we can do next question. Next question, write down. Next question, write down. Next question, write down. Next question, write down. Next question, no question. Where is the question? Where is the question? The pressure of a mixture of slightly saturated vapor, that means just saturated. The pressure of mixture of slightly saturated vapor, slightly saturated means just saturated, okay? The pressure of mixture of slightly saturated vapor and air at 30 degrees Celsius. Air at 30 degrees Celsius is 700 mercury millimeters. Is 700 mercury millimeters. Is 700 mercury millimeters. The saturated vapor pressure of water, the saturated vapor pressure of water at 35 degrees Celsius, comma, at 35 degrees Celsius, comma, 30 degrees Celsius, comma, 25 degrees Celsius or 35, 30, 25 degrees Celsius or ARE 40, 30, 23 mercury millimeters. 40, 30, 23 mercury millimeters respectively. When the temperature of the mixture, when the temperature of the mixture is increased to 35 degrees Celsius, is increased to 35 degrees Celsius by maintaining volume constant, by maintaining volume constant, find the new pressure. That means find the new total pressure. 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 I will use some time. I will use some time. Keep on doing quickly. Now, at 30 degrees Celsius, they clearly mentioned this water vapor is just saturated. This water vapor is just saturated. Just saturate it. Just saturate it. Now what we are going to do, we are going to increase the temperature. Now if it is just saturated, there is no doubt what is the pressure produced by the water vapor. At 30 degrees Celsius, if they mention water vapor is just saturated, what is the pressure of water vapor? Equals to saturated vapor pressure at 30. How much they have given at 30 degrees Celsius? Saturated water vapor pressure will be 25 mercury, no, 30 mercury millimeters. 30 mercury millimeters. So P01 will be 30 mercury millimeters. 30 mercury millimeters. Same thing. Total pressure is given at 30 degrees Celsius, say 100. Water vapor pressure is given as water vapor pressure equals to 30 mercury millimeters. Then you can find something from that. But they're asking something for total pressure at 35 degrees Celsius. They're asking total pressure of the mixture. Total pressure of the mixture at 35 degrees Celsius. Now, this will be careful. Think what would happen. Now, I said that just saturated scenario is really important. I want to teach you one important point regarding this. But anyways, I will give some time. The time is exactly 11:38. I will give 5-minute time. Let's check how we're going to do. Let's check how we're going to do. I'll start explaining at 11:43. 12 o'clock, we'll take a break. 11:43. So let's check. Think wisely. Just saturated, huh? Just think when temperature rises, what would happen? Sometimes one can appear as 2. Am I correct? Sometimes one can appear as 2, right? Twins. Twins. There is no doubt. Air means you can apply gas flows. There is no doubt. For air, you can apply gas flow. There is no doubt. But some people, they behave like 2 people. You know, right? Outside is 1, inside is 1. The peoples. That's the nature. That's the nature. Where is your hearing? You sold and you got that money and you did the payment for today's class. Oh God, how poor like me. Right? Normally girls should wear, right? That, no? Huh? Then it's good. Parents, they don't want to pay for these jewelries. Thank God. Parents, half of their salary is going to save money and to girls, jewelries, karabu, mala, mutu mala, walalu. Thank God. Then future boys' salary can be saved, at least. Seriously, it's a big concern, even though you agree or not. So one day you will suffer, okay? Advise all the boys, follow my advice, One day you know, you will understand. You like jewelries? Otesha, do you like jewelries? But some people, they say don't, but they want. Not to wear, but to store in their almirah. Am I correct? I'm wrong. I think I'm correct. They don't want to wear the jewelries. I don't know then why they are buying the jewelries.
but they want to store in the almirah. Some kind of collection of expensive things. I don't know why. So finally, who will get the benefit from that? Thief comes one day, jumps one day, entire that person's 20 years salary savings, jewelry, take it and go. Same thing happen in our home, not our home, our close by some homes. Yeah. So there should be a law in Sri Lanka to strictly not to use jewelries. For what's sake, right? Okay, 11:43. 11:43. You got the answer? I think it seems not correct. I think it's not correct. I gave a hint, right? Sometimes one can appear as two. He behave now. You behave like good one. You behave like bad one. That's our nature, right? Did you use that hint? No, right? You didn't use that hint, I think. Okay, we'll check. Anyone? Why not? Yes. That's the way. You got the answer in that way. Get. When will you get? You're also following that way, madam? You had that idea? Great. Wow. Wonderful. So we'll come to this girl. Great. So we'll come to this girl. Can you give my sorry? So it's okay. I will see what you have done so far. Oh God. Oh gosh. Do it. What is the time right now? 11:45. I asked. Time is right or wrong? I asked the time, man. You 11:45. ஏன் என்ன யாழே இருக்கிறீங்க மத்தைக்கு மாறுங்களேவா என்ன பிரச்சனை உங்களுக்கு Oh God. Really sad. I'm going to discuss that right now. Okay, then we'll take a small break and I will continue. I'll do it. Now you feel lonely, right? Your entire sit. எப்படி வா? This is for AR. If it is for AR, then you want to think about vapor. Think what will happen for the vapor. Now there's a problem with that. That's why I give a small hint. Madam. Beautiful diagram, but it's not a rowing class. Start writing something. 1, 2, 3, 4 equals. Start writing something. What about you? Why pencil? Next time I will throw all the pencils. Don't make me talk all these things. Use pen. You also use pen now. Okay. Now I will take these two pencils because I have two brothers. Go to the important point. Quickly. What's up, Amir? Still, no, that's not the way. That's what I told. It's not the way. So Dangal looked at me and he went. Oh. தேவா அடுத்தைக்கு போவா அடுத்தைக்கு எப்போ போவீங்க 10 நிமிஷம் செய்யறவங்க வராங்க ஏன் காத்துல இக்க வேணாம் கொஞ்சம் தண்ணி மிரி காத்துல மட்டும் இருந்து என்ன புரோசனம் நீங்களும் காத்துலயே தானே வைக்கிறீங்க ஏன் வா தண்ணிகளுக்கு போகணும் வா இடிக்கணும் ஒரு புல் ராசு ஒரு புள்ள செஞ்சானா இல்ல. Oh, no. You also, why don't you like water? Don't you like water vapor? You love only air? Water vapor?
Water vapor becomes portions of my.
No. Think wisely. Think wisely. That idea is wrong. What's up? Still no. Okay. Anyways, I'm going to start right now. I'm going to explain that. Okay, it's okay. I'm going to explain. I am going to explain. I'm going to explain right now. Okay. Now stop doing everyone. Now stop doing everyone and listen to what I'm doing. Okay. I told you that this dust saturated. This dust saturated is somewhat special. This dust saturated is somewhat special. I got 2 pencils for my brothers. If you have some extra pencils, send it over to me. I can give, because he asked before I'm coming, bring me a pencil, but I got 2 pencils. Okay. He's asking some typics also. Right. Now listen very carefully. Story is very clear. This story is very clear. Now I think you understood everything. Now everything is okay. Now we are doing questions. We are going to finish section. Once we discussed about AH and RH, section finished. Want to discuss about dew point, section will be completely finished. Now, I told you that the difference between saturated and unsaturated. Okay. This just saturated. It is in between saturated and unsaturated. Saturated, unsaturated, just saturated. Yes, just saturated is saturated. Just saturated is also unsaturated. The point what I'm coming to say is, depends on the situation. Sometimes we have to consider, we have to bias that person, either good or bad. The best example is, when we kill a person, that person is wrong. But when we kill a person in a war, that person is get awarded. Am I correct? Situation makes the person either good or bad. So very similar way, this just saturated. That idea, when we're doing questions, we need to consider, we can consider just saturated as saturated, if not just saturated as unsaturated. That should be decided by you, depending on the question. Very carefully listen. Stop talking, listen very carefully. Very carefully listen. Stop talking, listen very carefully. Important point. Important point. Then we'll take a break at 12. Then 10-minute break. Then until 1, we'll do questions. Then go home. Then next week again come. Now stop talking. Stop talking, huh? Just think that this is just saturated. Just saturated. This is saturated. It's an important point. If you understand this idea, finished. Unsaturated. Unsaturated. Now I say, now they clearly mentioned, according to this question, water vapor is saturated, just saturated at 30 degrees Celsius. Exactly at 30 degrees Celsius, water vapor is just saturated. Now only saturated. Right now, let's say now, at 30 degrees Celsius. At 30 degrees Celsius, let's say, if it is just saturated, at 30 degrees Celsius, if it is saturated, the maximum number of wave molecules here is, let's say 100. Let's say 100. Let's say 100. Now it is just saturated. That means what is the number of wave molecules in the container? 100.
Just only from 99 to 100, from 99 molecules to 100, just only it came. So when there was 99 molecules, it is unsaturated. So when it 99, 100. Now until 99 molecules in that temperature, it is unsaturated. So within small instant, 99 becomes 100, just saturated. So therefore, you know that this just saturated means. Okay, I think that I also. 99 unsaturated, 100 just saturated, 101 means 100 here, that 1 is liquid. 1 is liquid. 99 unsaturated, 100 saturated, 101 saturated. That's a problem. So therefore, what we can say, this just saturated is some kind of in between saturated and unsaturated. So what we can do, we can consider, depends on the question, just saturated as saturated or unsaturated. That's the idea. So I will give a note, but I will do the question first, then I'll give the note. Now clearly mentioned at 30 degrees Celsius, it is just saturated. Okay, very carefully listen, stop doing and look at it. Now air is also here, water vapor, we know it's just saturated. Just saturated. Then what is the pressure of this water vapor? If it is just saturated, the pressure of the water vapor is saturated water vapor pressure. At the temperature, how much? What is the pressure? How much? P01, how much? How much? 30 mercury millimeters. Now think what would happen when temperature increase from 30 to 35. Already explained. Raise your hands, how many of you say when temperature increase from 30 to 35? Raise your hands, how many of you say it becomes unsaturated answer? Now at 30 degrees Celsius, water vapor is just saturated. When you increase the temperature to 35, raise your hands, how many of you say water vapor becomes unsaturated answer? Now you can't sit properly. Now all of you should have one answer. Now we finished. I explained. Previous also I asked the same question. Answer everyone. Okay, now we are going to take a break also. At 30 degrees Celsius, water vapor just saturated. When temperature increases to 35, raise your hands. How many of you say that? Just because I wrote saturated, don't you say it? Right? When temperature increases from 30 to 35, at 30 degrees Celsius, water vapor is just saturated. At 35 degrees Celsius, raise your hands. How many of you say water vapor is saturated? Unsaturated. And now water vapor is unsaturated. Now here, water vapor is unsaturated. Okay? Air story is, same story. Air means you can apply gas laws, there is no issue. Now think what is best to consider. At 35 degrees Celsius, water vapor unsaturated. At 30 degrees Celsius, water vapor just saturated. Shall we consider this just saturated as unsaturated is better? Or considering just saturated as saturated is better. As this is unsaturated, we are connecting these two to be better to think just saturated as unsaturated. If we assume just saturated as unsaturated, what we can do? We can apply gas laws for vapor also. Previous question we didn't apply gas laws for vapor. Why? Those two were saturated. Now these two are unsaturated. So we can apply gas laws. Do it quickly. Now do it quickly. Air plus water vapor. Air plus water vapor. Now we know this, when temperature increases, water becomes unsaturated. So then we have to consider this just saturated as unsaturated. Then we'll consider just saturated as unsaturated. Unsaturated. Then it's all about applying gas laws for air and water vapor separately. Sometimes you can take entire as one and you can get the answer also. But I separately apply. Now do the question. Then we'll take a break. Do the question, we'll take a break. I will give a detailed note after doing the question. After taking the break, I will give a detailed note. Do the question. Oh God. So now, right. For the air. Now I know pressure of air, P1, pressure of air at 35 degrees Celsius, I say P2. Pressure of water vapor at 35 degrees Celsius, I say P0, P02. My target is to find total pressure. I say PT2. My target is to find total pressure, I say PT2. So when I consider this section, pressure of water vapor 30, total pressure 700, pressure of air will be 700 minus 30. So I can say that P01, pressure of air, P1. I can say pressure of air, I say P1 equals total pressure minus pressure of water vapor. 700 minus 30. 667 mercury millimeters. This is P1. Okay. Now what can I do for the air? Now, in order to find total pressure at 35 degrees Celsius, I need to find P2 as well as P02. Right? Now, please don't think P02 is now not equal to what is the. This is important. Some people still think that now what is the saturated vapor pressure at 35 degrees Celsius? How much they have given? 40. 40. Some people think that water vapor pressure at 35 degrees Celsius is 40. It's wrong. If this water vapor is saturated only, you can say water vapor pressure is saturated vapor pressure. But you came to a conclusion water vapor is not saturated. If water vapor is not saturated at 35 degrees Celsius, how you can say water vapor pressure is equal to that 40 mercury millimeters? Do you understand what I'm saying? Raise your hands. How many of you understand what I'm saying? Genuinely? Genuinely, do you understand? Genuinely, how many of you understand what I'm saying? Then how can we, then if I want to find total pressure, how can I do that? How can I find it? Applying gas laws for this water vapor also? Yes. Yes. Yes, apply. Please apply. First of all, I'll apply for air and I'll come to there. So I can use P1 over T1 equals P2 over T2 for air. 670. I know this. P1 over T1, P2 over T2. Then P1 is how much? P1 670. P1 670 over temperature 30 means 273 plus 30. 303 equals P2 means pressure of air at 35 degrees Celsius. Let's say P2. P2 over T2 means how much? 273 plus 35. 273 plus 35 means how much? 308. 308. Then my P2 will be, this is for air. Then my P2 will be equal to 670 over
303 into 308. What is the answer? What is the value? 681.3. This P2 681.3. Okay, now online students also, when you got the answer, put the answer chat box. Okay. If I ask you if you understood, raise your hands means you also raise your hands. Okay. Mercury millimeters. P2. But I want to find the total pressure of the mixture. I found pressure produced by air, that is this much. But I want to find the pressure produced by water vapor at this temperature. Water vapor is unsaturated, right? Therefore, we can't consider saturated water vapor pressure at 35 degrees Celsius. That means 40 mercury millimeter as the water pressure. Again, you want to apply water vapor for gas laws. Vapor, water vapor, apply gas laws. P1 over T1. When temperature is 30, vapor pressure 30. T1 means how much? 303. P02 over temperature 308. Finally, I'm getting P02 equals 30 over 303 into 308. What is the answer? How much? $30.5. As one mentioned, 30.5 mercury millimeters. Then total pressure, adding them. If I want to find the total pressure, it's all about adding. If I want to find the total pressure, yes, adding. The total pressure of the mixture is how much? PT2 means pressure produced by air plus pressure produced by water vapor. Okay. That means pressure produced by air, how much? P2. That is how much P2 means? Pressure produced by air plus pressure produced by water vapor. Pressure produced by air, P2 means how much? 681.3 plus pressure produced by water vapor. P02 means 30.5. Then altogether 681.3, 30.5 means 811, 711. How many of you got this answer? 711.8. Hands up. How many of you got this answer? Hands up. All of you? Online, physical, both. Hands up. What this answer? How many? Hands up if you got this answer. You got this answer. Hands up. Right, okay. Happy? Okay. Now genuinely raise your hands. Now stop doing. Stop doing. Now what we discussed? What we discussed? Vapor means gaseous state of any substance. In this section, we are talking about water vapor. First of all, you need to understand about how this wave pressure forms. Collision, linear change of linear momentum, force, pressure. Then we discussed about vapor pressure depends on several factors: temperature, volume, number of molecules, type of vapor. Then we started discussing about dynamic equilibrium between liquid and a gas. Okay, rate of vaporization, rate of condensation. Look at it. Then we understood what does it mean by saturated. Then we talked about what is saturated water vapor, saturated vapor. Then we discussed about unsaturated vapor and saturated vapor. Okay. So then what have we done? Then we discussed about if a space is saturated, the maximum number of vapor molecules depends on two factors: volume, temperature. I'm talking for water vapor, right? Saturated where pressure depends on two factors. Actually, it's one factor, temperature. Other one is type of matter. Okay. Right? Just saturated. Saturated means always think that some kind of liquid is at the bottom. Just saturated means depends on the question. We can consider just saturated as saturated or unsaturated. That's it. What are the sections that we learned until now? If you understood, please raise your hands. Raise your hands if you understood everything. Raise your hands. If you understood everything, raise your hands. Raise your hands. We'll take a break. We'll take a break. What is the time? 12:07. Come at 12:15. 12:17. Take a break and come. Go. Take a break and come. Then until 1, please don't yawn. Okay. Take a break and come. 12:17. Ah.
Right. Right, everything is okay, right? Yes. Yes. Right. Wrong. Okay, let's start. Next question. Want to go not? I'll go not. Right. Give me a second. Red color point. Now, this point is related to that question, okay? Separately, I will give a note, but this point is related to that question. Write down. Assumption, write down. Write down like this. Write down like this. Write like this. Water vapor is just saturated at 30 degrees Celsius. In the question, water vapor is just saturated. Water vapor is just saturated at 30 degrees Celsius in this question. It is assumed slightly, it is assumed just saturated water vapor as, 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 unsaturated water vapor. Unsaturated water vapor. Unsaturated water vapor. Okay, next point also write down this question. Okay, write down next point. When temperature increases from 30 to 35 degrees Celsius, when temperature increases from 30 to 35 degrees Celsius, when temperature increases from 30 to 35 degrees Celsius, just saturated water vapor at 30 degrees Celsius, just saturated water vapor at 30 degrees Celsius, just saturated water vapor at 30 degrees Celsius becomes unsaturated at 35 degrees Celsius. Becomes unsaturated at 35 degrees Celsius. Becomes unsaturated at 35 degrees Celsius. Therefore, water vapor at 30 and 35 degrees Celsius. Therefore, water vapor at 30 and 35 degrees Celsius are unsaturated. Therefore, gas laws can be applied for water vapor. Therefore, gas laws can be applied for water vapor. That's it. Next question, write down. Sample question number 3, write down. Sample question number 3, write down. Sample question number 3, write down. No need to write down sample question number 3. We'll continue that to sample question number 2 further, okay? Now this is continuation of sample question number 2, right? That question we discussed right now. Write down. Write down.
continuation of sample question number 2, write down. When the temperature of the mixture is decreased to, when the temperature of the mixture is decreased to 25 degrees Celsius, when the temperature of the mixture is decreased to 25 degrees Celsius, then find the total pressure of the mixture. 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 Now this is very similar to what approach? Now 2 sample question discussed so far. Sample question 1, sample question 2. Now the question, now this continuation is similar to sample 1. Okay, you can understand, right? Now do it. Then we'll do more questions. Now I don't give time, you keep on doing. I'm also doing by myself here. Now 30 to 25. Now temperature decreases from 30 to 25. 30 to 25 degrees Celsius. Air, water, vapor. Air, water, vapor. Now I say at 25 degrees Celsius, pressure of air, let's say P2. Pressure of water vapor at 25 degrees Celsius, let's say P0. Let's say now look here, when I'm doing I put a P note something. And normally this P note we don't use because this water is unsaturated. Normally we don't use this P note. Whenever this symbol note comes, it says about saturated. Okay, as a symbol okay, but understand normally we don't use. Now here pressure. Now you know. Look here. Stop doing. Look here. At 30 degrees Celsius, water vapor is just saturated. At 30 degrees Celsius, water vapor is just saturated. Just saturated. Am I correct? Then what would happen when temperature decreases to 25? Water vapor becomes saturated. It's very clear, you know. Look here. Idea is very clear. Now, sometimes still some people can't identify how I come to a conclusion when temperature decreases and becomes saturated. When temperature increases, becomes unsaturated. Still you can't understand. Very clear. Let's see at 30 degrees Celsius, maximum possible number of vapor molecules. At 30 degrees Celsius, maximum possible water vapor molecules is 100. Then what is the number of water vapor molecules existing at 30 degrees Celsius? Exactly 100. This is just saturated. Okay. At 25 degrees Celsius, when temperature, we know that I explained maximum number of water vapor molecules depends on 2 factors: temperature, volume. When temperature decreases, maximum possible number of water molecules existing in the container decreases. At 30 degrees Celsius, maximum possible number of vapor molecules 100. Then here it should be less than 100. Let's say 50. Let's say 50. At 25 degrees Celsius, maximum possible number of water vapor molecules is 50. But how many is already in the container? Already how many is in the container? 100. Then only 50 we can maintain 50 at the temperature as vapor. As vapor, we can only maintain 50 at this temperature. But already somehow you inserted 100. Already there is 100 in the container. At this temperature, we can maintain only 50 as the vapor. How many number of molecules should become liquid? 50. Now tell me whether it is saturated or unsaturated.
Whenever there is liquid, saturated. Very clear. Idea is very clear. I will give a note. Very clear. When temperature from just saturated instant to, if there is just saturated scenario, temperature decreases, it becomes saturated. Temperature increases, become unsaturated. That's the idea. I will give a note. Okay. Yes, that's it. Now do the question. Do the question. Do the question. If it is saturated, water vapor pressure is saturated water pressure. P not 2. Okay. I think all of you can do that question. Quickly do it. All of you should do it. Now time is 12:30. Quickly do it. And we'll write down a short note also. So we'll write down a small short note also. Now you get the answer. You have to get the answer. Get the answer. Get the answer. Now you can do it. If you got the answer, raise your hand. Okay. If you get the answer, get the answer. Get the answer. Get the answer. Now everything is included in this okay diagram. Okay, very clear idea. Now everything is included in this diagram. It's very clear. Look at this diagram. Look at this diagram. Next day also we have the detailed discussion regarding the graphs, variation of pressure, and it also takes time to explain the graphs. Now look here. At a certain temperature theta 1, this is temperature theta 2, theta 3. Now you know temperature increases from theta 1 to theta 2. Theta 2 is larger, theta smaller, theta 3 smallest, whatever. This is now here water vapor is at just saturation instant. When temperature increases, that water becomes unsaturated, right? So then we can consider, now this is unsaturated. In that case, we want to consider just saturated as unsaturated. So unsaturated here, unsaturated at theta 2. So these two unsaturated, therefore we can apply gas laws. Okay. Next important thing is just saturated means if the vapor is just saturated, understand vapor pressure is equals to saturated vapor pressure. If a vapor is just saturated, understand always vapor pressure is equal to saturated vapor pressure. If the vapor is unsaturated here, this is definitely unsaturated. This is obviously unsaturated. If the vapor is unsaturated, understand vapor pressure, the pressure at here is not equal to saturated vapor pressure. Okay. Now this story, when temperature decreases from just saturated to when temperature decreases from just saturated, what will happen? It will become saturated. Then this is also saturated. We need to consider just saturated as saturated. Can we apply gas laws? We can't apply gas laws. This one is also saturated. This one is also saturated. Definitely their pressure equals to saturated vapor pressure. Do you understand what I'm saying? Hands up, what I'm saying? You understand? Please write down. Please write down this one quickly. Short note. This is my beautiful short note. It's my beautiful short note. Write down. Short note. See, short note summary. Short note is there. Summary is there. Now one last question and we'll go home. No, ne. That note, ne. Need a book. Eat. Let's know these things. So then we'll do one question. They will do one question, and now you have to do that question, and you want to show me that question also. So that question that you are doing right now, you want to show me that question also, and I will give one last question. So then we'll go home. They will go home. What to do? Now, will you remind me next week, Saturday, that blank that you want to write a note? It remind me, not that day, one day before night. Okay. Okay. Quickly. Then now it's time to go home, right? Last 20 minutes. Happy? Last 20 minutes, right? You're happy, right? No? Last 20 minutes, time to stop the class. Now I think you understood. It takes time to explain everything, but once it is detailed explained, can easily understood. Right. Time is enough. So we'll write in the last question right down. Last question write down. Last question write down. Last question write down. A closed vessel contains a mixture of air. A closed vessel contains a mixture of air and water vapor. At 30 degrees Celsius. At 30 degrees Celsius. The water vapor is slightly saturated at this instant. The water vapor is slightly saturated at this instant. When temperature is 45 degrees Celsius. When temperature is 45 degrees Celsius. When temperature is 45 degrees Celsius. Find the pressure applied only by air. Find the pressure applied only by air. Find the pressure applied only by air in the vessel or in the mixture or whatever. In the vessel or in the mixture or whatever. Continue. What is the total pressure in the vessel? What is the total? That is something different. Yeah, continue, but what is the total pressure in the vessel if the temperature is reduced to 15 degrees Celsius? They have given inside the bracket write down
saturated water vapor pressure at 15 degrees Celsius. Saturated water vapor pressure at 15 degrees Celsius and 30 degrees Celsius. 15 degrees Celsius and 30 degrees Celsius are 1.7 into 10⁻³ Pascal. 1.7 into 10⁻³ Pascals. (4.22 10⁻³ Pascals. 4.22 10⁻³ Pascals. Initial total pressure 5 into 10⁻⁴ Pascal. Initial total pressure 5 into 10⁻⁴ Pascals. Find the answer. Find the answer, everyone. So I'll also do with you. Find the answer, everyone. Find the answer, everyone. Now, if you understood this idea, I think it's simple. It's still easy. So next day also, we take time to complete this vapor. So then conduction, convection, along with thermometry. And I will start doing this practicals also, don't worry. At least explanation of the practical, I will do it. Don't worry. So now only everything is going in a proper plan. I need some time to adopt. Now, initial temperature, it is how much? It is 30. Initial 30. 30, it is slightly water vapor is saturated at this incident. 30 to 45 are increasing initially. Initially 30 to 45 are increasing. To 45 increasing. Temperature 30 to 45 degrees Celsius. Now again, I think air and water. Sorry, air and water vapor. As usual, air and water vapor. As usual, air and water vapor. Air and water vapor. Now at 30 degrees Celsius, water vapor is just saturated. Water vapor just saturated. And what are the data given? So you want to find the pressure applied only by air when the temperature is 45. When the temperature is 45. Now look here. Now what have they given? Now they have given total pressure. Total pressure is given as 5 into 10⁻⁴ Pascals. Total pressure. Total pressure, I say,
at 30 degrees Celsius. Total pressure at 30 degrees Celsius, how much? This PT1 means 5 into the power 4 pascals. Total pressure. This total pressure will be, this is the total pressure. I know that I just explained. It is just saturated. This water vapor is just saturated at 30 degrees Celsius. Then, if this water vapor is just saturated, I told you water vapor pressure equals saturated vapor pressure at that temperature. Then, if you want to find the water vapor pressure at 30 degrees Celsius, find the corresponding saturated water vapor pressure at 30. How much? At 30, how much? At 30 given 4.22 to the power 3 Pascal. 4.22, this one. 4.22 10 to the power 3 Pascals. Okay. Then can't I find at 30 degrees Celsius, can't I find pressure produced by air? I say it is P1. I said it's P1. So my target is finding P1. First, no, my target is finding this P2 actually. My target is to find this P2 actually. If I can find P1, then problem solved. Then what can I do? Then what can I do? Then what can I do? Now, my target is to find pressure produced by air at 45 degrees Celsius. But if I can find the pressure produced by air at 30 degrees Celsius, problem solved. How can I find P1? Total pressure this much, pressure produced by water vapor this much, subtract. Then P1 will be equal to, the P1 will be equal to 5 into 10 to the power 4 means 50 into 10 to the power 3. 5 into the power 4 means 50 into 10 to the power 3 minus pressure produced by water vapor 4.22 10 to the power 3. Then 50 minus 4.22 means how much? 4.22 means 45.78. 45.78. 8. 46. Yes. Is P1. But my target is to find P2, then that low, pressure low. P1 over T1 equals P2 over T2. P1 is 45.78 something. My T1 will be, how much? T1 will be 30, 273 plus 30. We are substituting Kelvin value. Kelvin value we substitute. 273 plus 30 means 303 must be equal to, my target is to find P2. My target is to find P2, only P2. My target is only to find P2. Over temperature 45, 273 plus 45 means how much? 313, 318. 273 plus 45 means 380. Then my P2 will be, then my P2 will be 5.78 303 into 380. What is the answer? 4.80. 4.80 into 10 to the power 3. 10 to the power 2. 4. This value answer. There are many. So therefore, P2 this is the P2. So then next section they are asking, further they are asking in the question, what? They are asking in the question, what is the total pressure if in the vessel if temperature is reduced to 15? Now temperature reduced from 30 to 15. temperature reduced to 15. In that case, temperature reduced to 15, and you know that at 30 just saturated, 15 means saturated. Now this water vapor is saturated. This water vapor is saturated. Then this is also saturated. Then easy. Then what is the pressure of water vapor at this temperature? Now we know at 15 water vapor is saturated. Then what is the pressure of water vapor? Equals to saturated water vapor pressure. At 15, what is the saturated water pressure? 1.7 to the power 3 pascals. So this one's pressure is how much? 1.7 to the power 3 pascals. This pressure is how much? 1.7 to the power 3 pascals. Now we want to find the total pressure. If I can find pressure produced by air, problem solved. Again what? Again what low? Now I know P1 also. Again what low? Pressure low for these two. For these two, pressure low. P1 over T1, P2 over T2. What is my P1? 45.7 in the both 3. What is my T1? 303. P2 means air pressure. Now I see this is my P2. Now this is my P2. Now this is my P2, not that P2, this P2. P2 over 15 Celsius in Kelvin, 273 plus 15 means 288. 273 plus 15 means 288. What is my P2? My P2 will be equal to how much? 45.78 10 to the power 3, 208 over 303. What is the answer? What is the answer? You found, madam? .352 to 4.35 to the power 4. Okay. 4.352 to the power 4 pascals. So that is P2, but we want to find the total pressure. So we want to find the total pressure. Okay. Right. And then total pressure will be P2 is this much. This is the P2. At then, therefore, total pressure will be how much? Total pressure will be how much? 4.352 that 4.352 10 to the power 4 plus wave pressure is how much? 1.7 to the power 3. 1.7 to the power 3. Now 4.35 to the power 4 means 43.52 10 to the power 3. Am I correct? 4.352 into the power 4 means 43.52 to the power 3. 1.7 to the power 3. Add them. 43.52, 1.7, how much? 45.22. 4.522 10 to the power pascals. Got it. How many of you got these answers? Hands up. Okay. Today's story finished. So genuinely raise your hands. Whatever we discussed today, if you understood, raise your hands. So next Saturday there will be 2 classes, most probably. Definitely one class is their usual time. Evening also I will put that time also extra class. Then it takes another 1 day to complete this vapor.
Then we'll start the practicals in Unit 3 at least now. Without using the instrument, I will detail the idea. We'll take 2-3 practicals. We'll discuss them, and we'll start this conduction part. Okay. If Unit 2, 3, 4 challenging, Unit 5 finished, then 6, 7, 8, 9 interconnected, 10, 11 small things. That's it. So don't worry now. So we are also doing everything based in my side also. If the most difficult thing is managing, right? Once you know how to manage everything, you will be very successful, right? So you should practice managing everything. It's all about managing. How you are going to manage? Because the future, the professions that you are looking for, all biased to managing positions. Other than you are going with entrepreneur ideas, everything now, all the positions that you are seeking, doctor, engineer, pilot, all are managerial level positions. Therefore, you will be successful if you can manage everything. Now, currently, you don't have anything to manage other than studies. That's what I know. So even, don't know, you might have relationships, but those are very far relationships. Very far relationships, right? So only nighttime you will be active sometimes. But once your age is beyond 23, 24, 25, then you have to commit everything. Then you should, if you don't have proper managing, everything will be a mess. Definitely you want to follow a profession, you want to maintain all relationships in a healthy condition. No, seriously, right? And in case if you are planning for your self-development, then you want to manage the time and everything. So therefore manage. If you can't manage the studies right now, you justify, I don't have time to study everyday classes. Set. Everyday classes. Where to study, where the time to study? That's the biggest problem that you face. So every day until you die, you justify that you are failures. Every time you justify your failures. Yes, if I could have more time, I would have won that. That's how you justify. Because it's not because of my fault. That's how you therefore manage. That's really important. That is really important. Now your A-levels, it's not a big concern. But when the day that you are planning for you are reaching almost close to your goals only, you will face the trouble. Therefore, manage properly. And even once you selected for the future plan, now once you selected for the profession that you plan, you can't stay in that profession for a long time if you don't have good managerial attitudes. You become a doctor, you just become a doctor. Just every day that pharmacy, 300, 500,000. It's okay to earn. But then you don't have a growth from that to that surgeon, no, a therapist, or there are many. So therefore, you will be stuck in that doctor until you die. You write what? Prescriptions? 1,000, 1,050. It's a problem. Because whatever the profession that you want to go to the maximum. It's not enough to become just a doctor. You should go for the maximum position. Therefore, try to manage everything. That's really important. And talk, that's really important. Please talk. If you don't talk, understand now you're okay. After 2-3 years later, after this university, in case if you are going universities, once you finish doing your final examinations and when you get into the industries, it can be doctor or engineer or whatever. If you don't talk, you can't survive. You should talk. You should talk. Negotiation skills, number one for any profession. Negotiation skills. What we call bargaining. Bargaining skill is number one. right? Sometimes we don't like bargaining, but that is the number one policy. We should have bargaining. My father is really best in bargaining. 1,000, 2,000, those days 2,000 rupee shoe. Somehow you talk with that shopkeeper and he's reduced 2,000 shoe to now. It takes more than half an hour. My father he talks like that with that, and that person really getting annoying. That person thinking, yeah, even. Then somehow convinced to give to that price. So that is my father's talent. But now we think it as cheap mentality, but it's not cheap. That's what happening in high level industries. Bargain, negotiation. Can't you reduce? Please reduce. Please reduce. That is important. The talking skill is important no matter what is your profession. If you are becoming a doctor, you should talk. Even an engineer, you should talk. If not, you will stuck. You just be an engineer. You will never go in that organization. So even when you become doctor, you won't stay in throughout your life as a doctor. There are organizations. Doctor to chief doctor. Chief in the hospital, chief doctor. So then chief doctor to this, if you are going for a government hospitals, then there are positions. Then you won't be selected for them. Always until you die, you just be normal doctor. Therefore, talk. Practice a talk. So okay, talk. That's important. Talk. That is number one. You should talk. Therefore, practice talking. Sometimes now, what I will tell one story now. They are okay. No, I tell the story. Okay. Usually, I don't know. I talk. So now it's been only now. What happens in my life, I can say to you, right? Sometimes when we talk with the rightful person, now for an incident in my current working place, I talk with HR manager, HR head. He is the head for entire Sri Lanka Nestle. Okay, I talk with him. Because I talk with him, because I raised that issue with him, one thing in that organization changed completely. Because no one don't talk with HR head of HR. I talk with him, then he said, thanks for getting this point, and that is a big thing regarding this labor, white collar, blue collar, small issue. But that is changed. So therefore, talk. That's important. Talk. If not, you can't survive. Okay, class is finished. Okay, finished. Yes. Right, have fun. Next we will meet. iPhone battery நாசமா போகுது. முடிஞ்சு என்னத்த சொல்ல.